In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space-time, causing chaos and disruption. The world needed a hero, and Miller was ready to answer the call. With his flute in hand, Miller played a tune that echoed through the cosmos. Each note, a shot of pure ether, struck the Einsteinian demons, dispelling them back into the void. The world was saved, not by a warrior, but by a musician, a scientist, a man with a flute. Remember, in this universe of wonder and mystery, sometimes the most unlikely heroes make the biggest impact. Keep your mind open, your heart brave, and who knows, you might just find the ether within yourself. So here's to Dayton Miller, the flute ether master. His melody still resonates, a testament to the power of harmony in a chaotic world. In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift the very fabric of reality. However, a sinister force lurked in the shadows. The Einsteinian demons. These creatures thrived in the distortion of space-time, causing chaos and disruption. The world needed a hero, and Miller was ready to answer the call. With his flute in hand, Miller played a tune that echoed through the cosmos.
Easy there, Chief. Lad wants to see my ticket. Well, black and suck a dick. He's as dumb as rocks, and rocks had little pricks if they plans come.
All right, we are live, but we are waiting for Jaren's intro to roll through, and then we will begin. Got about a minute and a half left on that. Hello and welcome, everyone. We're going to have a nice cosmological discussion here. A little recap, if you will. Apologies for not having any background entertainment. Oh, you think we're not going to do a farm run just because Shane says so? Nah, dude, check it out. Can we squeeze one in before we start? Can it be done, lads? $30 seconds. Nice. Clock in some XP, log out. We made it just in time for the show.
All right, welcome everybody to, I guess we're calling this a conversation, if you will. Does Flat Earth have anything left? Or is it done? I believe one of us believes that it is done, and one of us believes that it's still got legs and truth and facts and evidence and all that stuff. So we're going to find out tonight. Have a little conversation with my buddy Alan from Space Audits. It is episode number 1. It is November 12th if you're watching then. Sorry we're late, or I'm late. It's not Alan's fault. I was at a auction in Fresno, and it went longer than I thought, so didn't get home till about 5. So 4 o'clock wasn't a good time to start. All right, let's bring him on and we will get going. There we go. Oops, that's the wrong one. We'll get it right eventually here. And there we go. Boom. Alan, say hello, everybody. Tell them who you are, where they can find you, and all that good stuff.
Hello, everyone. I'm Alan from Space Audits and/or Ether Cosmology. We are one and the same, or synonymous, or whatever they say. So anyway, if you want to find our work and research, you can join our Discord at discord.gg/ethercosmology. That's ether with an A. And then my YouTube channel is at space_audits. So you can find our work there. We do weekly presentations on either flat Earth or ether dynamics.
Tremendous. All right. So I know we're just going to, basically shoot the shit, try not to have any kind of moderation that we don't need. So I believe I'll let you start if you want to do like an intro, or how do you want to do that?
Yeah. So since the TFE, we've all been searching for an answer, right? Like none of us expected, or some people did, but most of us did not expect to see a 24-hour sun. And it really made us, rethink the paradigm, go back to basics. And I wanted to kind of touch base and share some of the research and things that have come along the way and regarding celestial and terrestrial measurements, and actually the history of flat Earth as told to us from the Chinese perspective.
All right. Can I ask you 3 simple questions to start, just so I get a feel for where you're at as far as did we go to Antarctica?
Yeah, I'm fairly certain you guys went. I don't contest that at all.
Yeah, no, it's just the main, the argument from most flat earthers is that we didn't even go. So that's a good start. And we did see the 24-hour sun. So you are of the belief that it takes place in the southern summer?
Yeah, and not only you guys, seeing it or whatever, but there's also record of the Chinese talking about it when they did their expedition in the 1400s. And there and I also found some Greeks. It was I can't remember his name, Animaxenes or something like that, Anaraxis or whatever. And Aristotle were one of those names, So anyway, Anaraxenes and Aristotle were getting into it, and Aristotle was like, "Well, what about the 24-hour sun in Antarctica, or like in the southern half?" And he was like, "Well, I haven't seen it, and I don't know if that's a real thing or not. But if it was," he basically invoked like terrestrial features that surround the Earth that would like block the sun at different times of year, kind of thing. That was his explanation for it, but he didn't seem to bother him too much. But yeah, the Chinese, which we'll get to in a bit, knew about it for sure.
So the first question was, did we go to Antarctica? You say yes. Is there a 24-hour sun? You say yes. Third question, do you believe that there's a South Pole that was 600 miles from where I was? Can we deduce that is in existence if we saw the South Celestial Pole? And we would have to assume what's underneath it. And we also know that people in different areas of the Earth can get there by all going towards the southern part of the sun. So do you believe that there is a South Pole?
Yeah, so I'm pretty sure there is. Like, you're just measuring latitude convergent lines, right? As they go together, and you would presumably have the same thing in the north. Like how it works mechanistically, we'll talk about the mapping of the world using the stars versus what an observer sees per their latitude. Because I think the difference is there. I think the difference there is that we see everything individually, but we're shown at least like these 3D models that have a God's eye view that kind of give us an expectation of physicality to the heavens, and like if this thing's over here, then nobody should see it over here. But the whole entire thing is absolutely designed from the top or from the bottom up, as an observer centric single observer to make the whole thing in both hemispheres. They used to have 2 separate star maps for the north and the south before they merged them together. But we can talk about that as we continue on.
Okay, yeah, just wanted to make sure. And then, props to you versus many of the other flat earthers that won't even have me on their show or won't even have a conversation and block me, everything else. So I just want to give credit where credit's due. At least he's willing to come on, have a conversation, and admit what the truth is, which is, yes, we went to Antarctica. Yes, there is a 24-hour sun. And I guess by extension, I say there's a South Pole. And we'll get into that. But I just wanted to make sure that those 3 things were covered. So you can go ahead and begin whatever you want.
Give me 1 second. Let me just add something to the notes for circumpolar stuff so we can talk about that later. Circumpolar orbits and travel. Okay. Circumpolar longitudinal orbits. Okay. So to start us off, I wanted to talk about the celestial theodolite and kind of give an update on that.
Okay.
So recently, a member of our Discord named Brian did his like extended the application of the celestial theodolite using eclipses, and basically the premise, which we'll watch a video here in a little bit whenever you're ready for it, but it goes over all the details and stuff. And I would also like, you know, to get as many globe lads to get eyes on it so that they can you know, refute it or point out, you know, flaws in the logic and whatnot. So but anyway, the
So
basic, go ahead.
what's the deal with that guy Jesse? So I know that he said that he thinks that there's lies within there, or that the numbers are fudged, or that it doesn't actually do what you say it does. When you say you have, you know, you want to get as many Glober eyes on it, have you considered having him look at it if he thinks that there's some sort of lie involved?
Oh, dude, we've had endless back and forth with him, and he does, like, not to get in. I'm not trying to slander him while he's not here or whatever, but to like give you a truncated recap, he does things like conflate the analysis between the globe prediction for the observer and then for what we're doing. He calls it the same method. He built a simulator to cherry pick observations because, like, as we can get into it, for the data, we're dealing with ratios of a triangle. There's should exist a location per each measurement where, you know, the globe would technically exist as for the measurement, right? And when we look into the data there, we can see exactly what he did, going to sea level and then finding the lowest possible hill to do the occlusion at, and we could see the difference in the numbers and what actually came out, because he went to a place where it's indistinguishable, not where it's one's better than the other. So like a lot of what he does is try to conflate things and make it so that nobody can get a conclusion or understand anything. So like
Okay. Would
and
you be
then
open to a debate with him then over that?
no,
If we had like on my channel or something? No. Okay.
no, we've
Because
been, yeah,
you've been through it a bunch of times.
we've been over it a bunch of times, and my last straw with that guy was the last self theo that we did with him. He was asking for the equations that we were using for how we were doing our derivations. I gave him the equations. Mike gave him the equations. We sent him PDFs of the equations. Like, this is all happening in the same exact time. He's screen sharing on Discord, so he has Notepad open. He's written down the equations that I give him, and he's in Discord telling people that I won't give him the equations. Like, I'm not trying to deal with that. That's a level of like,
Okay.
that's the equivalent of you didn't go to Antarctica. You know,
Well,
at that
yeah, I'd have to
point,
see what you're talking about. I mean, to me, if he's saying that it doesn't work like you say, or that it's cherry picked, or that, because I mean, really, what science is repeatable predictions, right? So the celestial theodolite should make better repeatable predictions than the globe, and I'm not sure it does that. From what I've heard, it's, you know, these couple times it works.
yeah. So
I'm not trying to take away from anything
no, you're good.
present.
There's a difference between that's not what I've heard versus I've looked at the data and I can confirm
Sure.
everything that's being said. That's an extremely important aspect of this whole thing, because a lot of people are relying on what that guy says and what Ruhiv says, and
Well,
they're not.
True. I mean,
So,
but I'll say that
you're looking at it through a filtered lens of
I'll admit that.
of what they want you to see about it.
Okay. And is the truth still that we are not including refraction in this?
We're not including refraction in it because the occlusion process is a physical process. So in other words, refracted light isn't going to intersect a refracted mountain, right? Like, and I can show you some examples of what I mean by reflected.
Okay, I'll let you show me.
By that not intersecting. So in other words, it requires the physical intersection between the source and whatever the mountain in this case. So what they'll try and do is they'll say, well, I want to add terrestrial refraction to the mountain because that'll make it match what a theodolite measures, but that doesn't cause an occlusion. That doesn't tell us anything about the occlusion. That just raises the apparent level of what it is, does nothing. And then on top of that, the astronomical refraction, the same situation. If it's refracted light, it's not going to get occluded through a refracted image, only when the source intersects, which you'll see as we go through.
Okay. And then, so that video I saw from Goose, doesn't that show it that refraction does affect the view?
Yeah, that's our premise, that it affects it when the physical intersection occurs. Because what happens is it gets lifted up a little bit, and then the angle, which the physical thing that's emitting the light, has to be a little further behind the object before it actually gets occluded. So we're saying, when we're not accounting for refraction, we're saying that between you and the mountain, the refraction doesn't matter, because on the back end of the light that's coming from behind the mountain, when that stops coming to you, it's no longer being refracted over the mountain, right? Like that's the basic. When we say we're not accounting for refraction, that's what we're not accounting for. When the star is no longer visible, it's no longer refracted, and we just want to know where the light source of it was at the time that it was occluded. It's like it's almost so straightforward that it can only be only through like misrepresentation can it be confused.
Okay, well, I hope you're going to show us as because that doesn't make sense to me. I mean, anything that you're looking at and it gets blocked. I mean, it's just like the sun, right? You know, the sun is, well, again, I don't know if you believe that, but the sun is said to be below the horizon, and we still see it. So it's up above what's blocking it because of
Yeah,
refraction.
yeah, they certainly do say that.
Okay,
But
you
that
just
doesn't.
you just disagree with that. Okay, got you.
Yeah,
Um,
just watching the sunset alone wouldn't tell you anything unique about the situation, because what they're saying is either true or there's just a lingering effect due to optics, and then as the sun goes away, it can't power through the atmosphere that it's that's between us and the light source. So either
wait, so
way,
you're saying
the same effects
atmosphere has
wouldn't be
something to do with the
coming
sunset?
in. What's that?
Are you saying atmosphere has something to do with the sunset?
Yeah, there's light attenuation, like the mix and
Okay,
opaque layer, all that.
but if atmosphere had anything to do with it, then we wouldn't be able to predict the time because we wouldn't know the atmospheric conditions. So you would not know what the sunset. I can tell you what the sunset will be on Friday or next Monday or in
Yeah,
3 years.
yeah, but you're basing all that off the apparent position anyway, which is predicated on knowing the atmospheric conditions anyway. So whatever it happens to be is however much refraction there happens to be. What I'm saying is either way it sets, just watching it set doesn't tell us anything unique about the situation. Because there could
Okay,
be, because like our premise is the sunset is an optical phenomenon, where you guys say it's a geometric phenomenon. Right?
right.
That's the big difference. And just
And if
watching
and
it
if it could be
alone
timed, then which
tells
one
us
would be
nothing.
true?
Well, just watching the time of its setting doesn't tell us anything unique.
No, what I'm saying is
It could go either way.
tomorrow.
That's
So
what
we
I'm
know
saying.
the sunset time tomorrow, right? But we
Hmm.
don't know the atmospheric conditions. It has nothing to do with the sunset time. The sunset time is done geometrically, not has nothing to do with the atmosphere. The atmosphere. If tomorrow ended up being a cloudy day, it's not going to change the time of the sunset.
Are you aware though that the whole model is that's not predicted; it's post-dicted off of when the sun
Sure.
returns. So after you have enough data and you can say that, like that's all it is. So what we're saying is that it's an optical phenomenon rather than a geometric, and just watching it and saying, but what about the prediction? It's a post-diction, so it literally can't tell us anything unique about the
So give me
situation. Just
another
saying.
example of what an optical phenomenon is. What's an
Optical
optical phenomenon? Just give me
phenomenon.
one so that I can
There,
see if we're talking the same thing. Because you're making it sound like if it's an optical phenomenon, then it would be it would vary due to
okay.
optics.
Yeah, so like you take the example of when a car is coming at you and it has two headlights, but when it gets further away, it just becomes one headlight. So like
Okay.
that's facilitated by an optical phenomenon. It doesn't have anything to do with curvature or anything like
Right.
that.
And it has to do with the atmosphere, meaning that we couldn't predict the time that would happen because it would vary based on what the conditions were.
Okay, then
But we
just make it solely based on an optical phenomenon. That way, at the time's the same no matter what.
so I asked for an example of that
The
because
sunset, the same thing in question that you're invoking. That's why
okay,
it can't tell us anything unique. That's why we need another variable. So, for instance, if you were to do a self-theo occlusion with the sun and a mountain or whatever, like you can make some determinations based off of the true position versus the apparent to see how much refraction and whatnot is actually affecting the stuff. But just watching it alone tells us nothing.
but predicting it. That's what I'm saying. I mean, if we're just watching it,
Yeah,
no, yeah, right. But we predict it. We know what the sunset will be tomorrow, and
you
it has
didn't
to do
though.
with
You
we
didn't.
didn't.
No, it goes in a cycle, bro. We
Yeah,
just
yeah,
went
no, but
over.
that's because it's time.
That's called a post-diction. If you know
Sure.
if you know it's cyclical and you know where its position's going to be 20, like that's not a prediction. That's just a cycle and a post-diction.
Okay, so you're saying because it already happened, and then we are predicting it in the future. It's a post-diction, not a prediction. Okay, so we know what time the sun's going to rise tomorrow or set tomorrow because it's happened on that day of the year in the past, right? So you're saying because we know that, we can predict the future, and that's the only reason we can predict it. But if
Not
there's two models at play, flat Earth and globe Earth, and one of them describes why it is that we can predict that, and the other one says it's atmospheric, which can't be responsible for predicting it. So then
okay.
wouldn't there
Like
be a clear
well,
winner there?
like I just said, take out the atmospheric effect. If you're not accounting for it either, then we could just reduce it down to either optical or geometric. It doesn't matter. Like it's the same situation. Just watching
Okay.
it tells us nothing
Okay,
about
go
the
ahead.
truthfulness of either model. All right. Okay, so yeah, the goose video, though, that was illustrating that the differences in the occlusion time and how that would affect it. So what we're saying is that when the star gets blocked, whatever refraction was occurring, it can no longer overcome the mountain. Whatever refraction or optical or whatever is happening, it no longer overcomes the mountain. And we want to know where the true position of the star was with respect to the mountain peak at that time, because that's what is aligned for us with our field of vision. So we need to know, like, if you think about that as the crosshair, like the mountain as a crosshair to the theodolite, so to speak, we want to know, or, you know, we go to the mountain peak to see where the stars align, to see if it's still aligned with our crosshair. That's all we're doing.
Okay. I guess where I'm confused is that, so then can't we just call what you're seeing in the celestial theodolite an optical effect that it doesn't tell us anything about the shape of the Earth?
No, because there's a new variable there. There's an independent variable. So there's
Of what?
there's our distance relative to the control, which is the altitude of the mountain. So that's going to produce a unique angle, and that angle is going to be is dependent on the physical elevation of that mountain. So relative
And where are
to
you getting the information about what the angle should be?
where are we
From
getting the
Stellarium, right?
elevation to? No, we're getting the elevation of where the mountain should be based off of like Wikipedia, like whatever the mountain source says. So Wikipedia, NOAA, any sort of reference that has the official numbers for the altitude of the peak.
Right, but where are you getting where the star should be in relation to that mountain?
Oh yes, yeah, from Stellarium.
Okay, which is globe based, yes?
It's the nautical almanac that uses latitude and longitude, and all that is positions of the stars with respect to where they were at a specific time. So when we talked earlier, now the answer to your question, the quick, yeah, it's a globe tool or whatever, that would be like the easy layup, right? Because it's a sphere, right?
Oh,
All it's doing is showing you where the stars are at for an observer at their latitude. So it's again, when I was talking about that God's eye view perspective that gives us that misconception, right? All we're looking at is where some dude took a zenith measurement of a star, and then uh, uh, 24 hours later that star came back to that position. So we're looking at a series of the whole model being put together like that. It doesn't mean that the Earth is a globe. They do a geocentric transformation to the center radius of the globe, right? But we'll get into fictitious coordinate system transformation stuff if you want, to show that doesn't mean anything. So like, check this out. Even in if they're using a geocentric transformation, right? What they're doing is they're going to the center of the Earth and they're saying, okay, you're in the center of the Earth. And then the actual surface of the Earth is a hollow sphere, and the celestial bodies are fixed on that, and they're rotating around you. But one observer only sees that one hemisphere at a time.
right.
So so when they go and they're not visible anymore, that's either due to them going on, you know, due to the Earth being a ball, or it just being part of that same optical phenomenon we talked about, like a limit of vision. So if something goes so far away that you can't see it, that's our position. And we're saying that the way that it's mapped out, and especially with them using negative coordinates to describe things that are so-called below the horizon, there's no difference in mapping that out and merging it together. It doesn't mean anything.
Okay, so you talk about a limit of vision, but isn't it true that anybody anywhere on the Earth can always see half the stars or thereabouts?
Yeah, that's exactly what I said.
Okay,
In
so I'm just, well, that seems,
in your field of vision, that's what you see celestially. So the celestial, or what are
so you
they?
perfectly see half of a sphere
Yep,
in your vision,
yep.
half of the stars. So how would that work on a flat plane? I mean, if I gave you a flat map and then I said put this dome over it so that the people see half the stars, kind of like in Shane's model, right?
Yeah, it would
But
work
the
exactly
problem with
like
it is there's a
this.
lot of other Earth there where there's more space there for people to see more than half the stars.
It
On
works
a globe, you can only see half. Are you
it
sharing?
works yeah. Oh yeah, sorry, real quick. Yeah, it works it works exactly like this. Right. So you
Yeah.
only see, so instead of seeing this all this out here like this, you see it only projected into your half where you're at.
Right. But I'm saying
It's
that is exactly half of the stars in that dome. But then other people all over the rest of the Earth also only see half.
it's latitude dependent and observer centric. It's the same thing as this right here. Check this out. Let's see. Theo, go over to here. So this is Shane's half projection hemisphere, right? Or Walter Bislin, whoever you want to say, or even the Chinese and Japanese, right? We have this hemisphere of vision. Well, this is the globe. Same. Oh, this is the globe variant of it. Same exact situation. Same thing. They're literally identical, and they all require. They're all observer centric. So
Okay.
there's. That's why.
One,
Go
one of
ahead.
them makes sense because there's only half the stars are visible for that person on the globe. The other half of the stars are blocked by the globe. So but there's no, the explanation from the flat Earth has to be distance related, that we can't see stars because of their distance, right? Or just it's magic. Because the globe has an actual reason. It actually explains, it actually describes. Whereas the flat Earth is just, believe us, bro, that light works this way. It puts the sun exactly where the globe model calls for it. It just seems to me like what it does. When you go back to Shane's model.
Yeah, listen.
It,
When something, everything arcs across your horizon the same exact way. Everything goes from the top, right here, like at your zenith, and then as it gets further away, it gets lower in the horizon. That's true in both models as an optical phenomenon. It's just when you can't see it, you guys are like, well, that's because the globe is blocking the half. We're just saying that's where the ground meets the sky, and that's as far as you can see.
Okay, so what about when, let's say, circumpolar stars in the south, those go around the pole star, that's their full night's travel, yet the star's on the complete other side of the Earth. Right, the southern stars are the outer edge of the sky dome. Right, the stars are, I mean, I could show you if is that you, that's not Shane's model that you can play with right now?
So there's two hemispheres of stars.
Right. So go is that okay? So go to that one and push the person out to like latitude 55. 55 south. Yeah. So go there. Okay. So let's say there. And then turn on the stars.
I don't know how.
They should be at the top. There's a on his go up there. There's like a button that says stars. And you just like press a button or something that shows up. Stars. There they go. Okay, so now let's get a look at it. Wait, it moved you, huh? Go ahead and go back to where we were a second ago. I don't know why it's moving you. Latitude again, 55 or something. South. Okay, so see the red stars at the that go around Sigma Octantis?
Yep.
Okay, so if you pull the time forward a little bit just so we can see that in a day, those stars just circle. But those are actually the southern stars, which means half the night they're on the other side of the Earth. So if it's distance dependent, then we would be able to see Polaris, because how could we see stars further than Polaris? Because those red stars are not, the southern stars are the outer edge of the stars. There is no stars that stay and circle like they do in the north. So think about the circumpolar stars in the north on a globe or on a flat Earth, they both work because the stars never set, because they just stay right above the North Pole star. They stay right around it. They get orbited overnight. Okay, great. Now, if we go to the south, the same thing happens in the opposite direction. Yet you're telling me that the stars that we see are just, you said they basically rise and set. Everything's the same. Well, it's not the same, because those stars there on the globe are actually there. They actually just circle the South Pole star. Yeah. Whereas on your flat map, we have to pretend now that somehow those just manifest over there.
Yeah, I got you. So okay. This is conflating the two things as like a God's eye view perspective. Nobody sees the full spectrum of the stars like that. It's the latitude.
No, but I was down in the south and I saw the southern pole stars that just go around it.
Yeah, I don't disagree. That's a latitude dependent phenomenon in, like, as you're away from the equator in the south. The same thing happens in the north for the north lads. Okay.
But the north, the north stars are actually there, right? The north stars are there.
And the southern stars aren't?
No, you just told me that those southern stars that just circle the dome there, you're saying that those are the outer edge of the stars, so they actually travel all the way to the other side of the Earth.
That's not what I said. I said that's a latitude. Seeing them and how you see them is latitude dependent, whether you're north or south of the equator. That's my position.
Latitude dependent. Okay. So, of course they're latitude dependent. I mean, what you're saying is that it depends on where you're standing, what we see in the sky. Yeah, no shit.
Right. But then you're turning around and saying that it doesn't matter and we should see Polaris from down here.
So the stars that are in the south are the outer disk of the stars, the outer rim of the stars. That's the southern stars, right? Yeah. Okay, so as the stars go around in one day and do a circle, those are the stars that you see go around Sigma Octantis, the ones that go all the way to the other side of the Earth. So when you see them up right next to the South Pole star, they're really on the other side of the Earth over by Australia. which is further than Polaris. So I don't get how we can say that it's just magically appearing there. I mean, that's why this is a stolen globe projection. So, well, it is. I mean, the people in the South. So do you know that that's exactly what you're supposed to see from the South according to the globe? That half hemisphere is exactly what the globe predicts.
Did you know that it's also what a flat Earth predicts with 2 star fields for a map?
Okay, but it's not what a flat Earth predicts, because a flat Earth tells me that those stars are on the other side of the Earth. That's what the flat Earth predicts. You just moved them. You just said, that's what the flat Earth predicts, and then you moved it to where they're supposed to be, and you said, okay, that flat Earth predicted that. No, it didn't. You moved them there.
Only when you're speaking through the God's eye view perspective. If we're talking the ground positions of the stars and what they're physically mapped to, they're separate for a reason. That's why they used to have 2 separate star fields. Merging the 2 with the fictitious observer in the center.
Yeah, they had 2 star fields because there's the north and the southern stars. 2 different sets of stars.
And that phenomenon can't exist on flat Earth because
the southern stars go away from you all the way to the other side of the Earth, but I still see them in my dome sky. They still stay there, but they're the southern stars. In the north, it makes sense because they are there. The north stars are there. But in the south, if it's the outer disk, then so like play the stars that go around Sigma Octantis. I just don't know if people realize this. Go back to right there, and then just play the day of time of day. Is that day? Okay, so all those stars that are spinning above your head in the south are actually going around the Earth on the outskirts. They're not going around the pole star, or else they're going around the pole star of a globe. Well, so you're saying that the southern stars in your mind are actually staying there and going around the south pole? Because let me explain. If you're over in Australia, you see the same stars circling the same South Pole star. So they also have to see the same stars in their sky. And then so it's just everybody on the outskirts of the Earth sees the stars no matter where they're at on the outskirts on the other side. Yeah, I mean, it doesn't work. It just doesn't work.
I don't know how it doesn't work, because the Chinese went and did the exact same thing. They mapped out the southern the exact same way they mapped out the south. What they did is they went to the Falkland Islands. They went to the star Canopus, and they got almost to the zenith. Like, they had it at like 88 degrees under their zenith instead of 90. And then they mapped everything out with latitude dependent effects based off of that. And they used, hold on one second. And they used,
but it's just when you're saying latitude dependent, that's of course, everything is latitude dependent.
The single observer latitude dependency is key here, because you keep,
but that's no matter what. No matter what. Who believes differently than that? Who believes it's not latitude dependent?
Because you keep conceptualizing it as a unified total model, and that's not.
No, I'm saying
an observer sees per
talking about what an observer sees. So do me a favor, grab the longitude and move the longitude and watch what happens, and tell me this is just by accident. Do you see that?
Mm-hmm.
So everybody on the outskirts of the Earth sees the pole star completely in an opposite direction. Notice those people see it over there. Those people see it over there, but it's the same field of stars. So clearly there's a model that says there's a reason for that. And the reason for that is because you're at the bottom of a globe and you're all looking in the same direction to the South Pole. That's telling us that the South Pole star is in a different direction for everybody. So, I mean, it's kind of, now if you move the other way, move the latitude line and watch how it just unfolds perfectly. It's a sphere that latitude, sorry, that one. If you just kind of watch it roll, that's a sphere. It just works perfectly. That you have the North Pole star, and then as you go out towards the edge, now the South Pole star unrolls, and now we can see that in the sky. So it's just funny that I didn't know that you still think that it's this map. Because if we want to show something else, now go to is the sun on there?
What do you think this map is? This map is just the positions of the stars on the vernal equinox. That's all this map ever was, for 2 separate hemispheres, and then merged together mathematically. What these observers are seeing, like, they don't see it all at the same time. They all see it on the same latitude. So
they don't see it at the same time because it's time dependent.
What I was saying though is that the Chinese went and mapped all this out as geocentric flat earthers using Canopus and then the southern Sigma Octantis, but there's 2 stars that lead it because Sigma Octantis isn't bright enough. So they used those 2 stars.
They have been wrong.
Hold on. No, they were identical, because later on we can get to an eclipse method that they use to come up with how to determine longitude. and it's identical to what's used today, like 1-to-1, like the accuracy. I'm pretty sure that the Jesuits took the Chinese model and then combined it mathematically, retold a whole story about how they needed to get a synchronized clock so that they could tell time at sea. The Chinese already did all of that in the early
Can you? I'm
1300s.
sorry. Can you turn on the paths real quick so we can see them? There's a button, I believe, to turn on the light paths.
Yeah, you want to see some bendy light or whatever?
Yes.
Is that it?
I don't remember where you do it. And then, do we see the sun or no? I can't really see the top of that. Where's the sun at right now? Don't know where the sun is. Do you have to turn it on up top or something?
Sorry, we're on star mode. There's no sun right now.
Okay, you can't. Let's bring the sun back just real quick so I can see. Okay, so that's the sun. Oh, it's kind of doing a video. So on the day that we saw the sun south of us in Antarctica, when it's actually over Australia, is there two suns? Or explain that to me, or what you feel now that you know that there is. You said earlier that you think there is a 24-hour sun. So people in Australia.
Yeah, we all see our own individual sun. All the stars are all individual to us relative to whatever latitude we're at. And I can show you that despite this projection in the globe saying that, well, the reason is that the sun is underneath you and all that because of the converging latitude lines, I can show you that over 7 million meters, the sun doesn't drop in elevation, the sun and the moon. Because like the big takeaway here, like forget about the socio-terrestrial measurements of mountains and stuff for a second, and like just observing the stars and where they're at and making a map based of it and having converging longitude lines and all that. Because like all that's going to work out mathematically per the latitude, or I'm sorry, per the hemisphere that it was mapped to. But when we introduce the physical occlusions, like what's blocking out the sun to create a shadow over the ground and create triangles with that per every observer at their location, what I can show you is that the sun and the moon do not change in elevation. So they're always parallel to the ground. That's the most significant thing put forward here, because all we're discussing is how apparent positions were mapped out. And to quote from Copernicus, if you're following what was conceived by astronomers for another purpose, i.e. conceptual models for ease of teaching,
Right.
then you'll leave astronomy a bigger fool than what you're talking, or than when you entered. And what I'm proposing is unique because we're using the so-called light source of the object rather than the apparent position. So based on what the whole model is based on, it's not even based on the apparent positions that we see necessarily. It's based on the time that true position will come back in 24 hours. Because as these things get lower in the horizon, they end up lingering, and they don't follow the 15 degree per hour relationship at that. So everything is actually based off of where the light source is from the zenith measurement taken on the equinox, and then
Earth to inside that viewpoint for that person.
No, we don't have to we don't have to do that at all. It's single observer built, man. And then what was the other thing you said real quick? Oh yeah, about the globe model. There's no globe model, bro. What you're looking at here are latitude and longitude lines.
Hold on a second. What do you mean there's no globe model? Go to Google Earth. That's a globe model.
Okay, and I'm going to explain to you what that's representing, right?
Okay.
That's put together from latitude and longitude lines. Latitude and longitude lines are just positions of where stars transited.
But they exist on a globe. That's where they were drawn.
You're saying that they exist on a globe, but you can't know that just from the apparent position alone, just from mapping them off of a cyclical nature, just by mapping their apparent position. And when they come back, that doesn't tell you anything unique. That could go either way. And then
there's a model that calls for that, and there's a model that needs a lot of help to get that.
These are the same thing. This isn't a model. This is a latitude and longitude coordinate system, bro.
Okay, so go to 70 degrees, go to 80 degrees south, and like minus 120 east or west, just so we can get kind of where Unit Glacier is. Is it working there? I could bring it up too. I wanted that little dome on there. I don't know why the dome disappeared.
Yeah,
I'm
not sure what happened either. Give me a second. Let me refresh. Yeah, there we go. It's back. It's back. I got you.
Okay. So, yes, thank you. Let me go in here. I gotta get back to the screen. I lost it. Where are you? Okay. So, and then, where are you at? I think you went 90 degrees. So go to 80 degrees just so we can get off the South Pole there. No, I'm sorry. Latitude 80. What does that do?
Is that
Okay,
not
I guess so.
that
I
is
guess you're right
right.
there. Okay, I can't see it moving. All right, so there, and then put the sun or put the date where it says day of the year. Put it like 3:55. One of those says day of the year. Do you see it? Like maybe go 3:55 ish. Okay, and then there's the sun. All right, so now put the sun at where it's off on top of Australia. Oh, I see. You're at the bottom of South Africa. Sorry, can you do the longitude? Move that for me just to Union Glacier, which is going to be like, yeah, take it the other way. No, the other way. There you go. Right around there. Back about 120. There. Good. Okay. So now take the sun over to where it's above Australia, which would be time of day. Is it there? Okay. So now the people in Australia see the sun above their head and they're getting heat. It's heating them. And then the people in Union Glacier see the sun on the opposite wall. So there's two suns. You're saying there's not two suns, or there is two suns? You're saying everybody has their own sun? There's an infinite suns?
Everyone sees their own individual sun that's latitude dependent. So what you're looking at is how you're going to perceive it in the southern hemisphere. It's going to do an Antarc for you as the true position of the sun circles above us parallel to the ground, as noted by the eclipse data that we'll get to.
Okay. So let's say it is parallel to the ground. That's fine. But I'm saying it's way over there. It's 30,000 miles behind me, but it just appears on that wall.
Oh, no, that's not fine. It refutes curvature conclusively, because there would be 4 million miles of curvature to that 7 million mile distance based off of an elevation of the sun being 6,731 meters high.
Wait, what?
Yeah. Well, we haven't got to the.
But you're saying something moves parallel, but you mean it's moving level.
It's moving parallel to the ground. Yes.
That's called level.
Sure. Level to the ground.
Yeah. So that's a curved path.
What?
You understand the definition of level?
Nah, dude.
Okay, well, so level and horizontal now are the same word. So we can just replace one word with the other. They don't mean anything different.
So listen, when I say they're parallel to the ground,
I'm asking you. I asked a question. Okay, but I asked a question. Can we just call level things horizontal now and horizontal level? They're the same word? Because you just laughed because I said they're different.
Horizontal, straight, and level. Level doesn't mean curve. Level meaning curve is like redefined so that they could talk about.
So then you're saying that there's two words.
Orthographic projections of an ellipsoid model and all that stuff.
No, it's just the definition of level. Level is from a certain point. So if you're saying level from the center of the Earth, then the oceans are level on a globe. That's how it works. You can laugh at it, but that's how it works. You have to admit that's how they say it works.
That is exactly how they defined it. Well, what I'm talking about here, right? So do you understand that if Stellarium is a globe tool and all this stuff and all this globe stuff, that the elevations, the true positions have to actually change in elevation because the contour of the Earth is, we'll take the rotation example, right? The elevation change is physically being created because the curvature of Earth, right? So the the true position of the star would also have to change as well. That's what the whole model is predicated on. And when they say that when there's an observer standing here and that star is setting into the horizon, they're saying that its true position, its true elevation is now at 1 degree. Now it's sub 1 degree. Now it's negative coordinates. Now it's under the ball, right? What I'm showing you, what I can show you is that during an eclipse over the course of 7 million meters, where there should be 4 million meters of curvature, there is none. There's a 10,000 meter deviation. That's it.
Oh, you'll have to show that. I have no idea I don't even know how far 10,000 meters is. 30,000 feet?
10,000 meter would be
6 miles?
No, 10,000 meters is like 1,000 kilometers. So whatever 1,000 kilometers is in miles.
Oh, 10,000 meters, sorry. Yeah. So that's 30,000 feet. 30,000 feet, 6 miles.
Sorry, did I say 6 million meters or did I say 600,000?
I don't know. I got very confused.
It's
meters.
6 million meters comes out to
6 million. It seems a little high, though.
So in kilometers, though, that's just 6,000. So whatever the conversion is from thousands of kilometers to miles is what you would.
Okay. I don't even give it what we're talking about there. I don't know how the eclipse has something to do with this model.
It has to do with all models that use the latitude and longitude dependent, especially those in particular that say that the reason that the stars aren't visible is because of the globe. is blocking them because the physical elevation is changing. That's the
So
whole
where I'm
purpose.
confused is if, let's say I'm in California and I say that the sun is a certain distance above my head, and then hours later, when it's above the head of somebody in wherever, Hawaii, it would be the same distance above their head. So I could see where you're just drawing that and saying, oh, look, it's a level, it's a flat line. It's flat the whole way. But yeah, because it's staying level, it's the same distance from the earth, no matter where it's at. I mean, not at the same time when it gets above their head versus above my head.
Exactly.
Obviously.
And we could plot out the whole thing and show that at no time is it ever going under anyone's head at any angle. That's the
Well, we see from a plane, you can see the sun
do,
below your eye line.
when we get to do you just want to watch the video real quick so we can, because this
Yeah,
is
we can.
like
Let's get to that. Yeah.
you're getting half of the argument is not doing any.
Okay. Yeah, I'll watch this video you want to watch, and we'll
All right, thank you.
go from there.
All right.
No, but I think it's a lot simpler than what we are talking about. But go ahead. Yeah, I'll watch this.
Yeah, go ahead. Thank you. I appreciate it. All right, so I got it playing at 1.5 speed, so it's pretty normal speaking tone. It's not too
Okay.
fast. Now that'll reduce the time to 13 minutes and 30 seconds, so we don't have to do the full 19.
Okay. Tell everybody what we're watching though, so that we can.
Okay. Yep.
know
Okay.
what's
So what we're about to watch is a brief recap in the celestial theodolite and what we mean when when the true elevation of the star is traveling parallel to the ground and it's not actually deviating like it should as per the globe requirements. So Brian gives a nice little recap on that and what the triangle situation is, and then what he's going to do is he's going to independently derive the altitude of the moon using the total length of the shadow produced during an eclipse, and then from that he's going to derive the altitude of the sun based off of the occlusion from that, and then we're going to plot that out over all the observers for the 7 million meters that the shadow length was as the eclipse occurred. So as the eclipse occurs, we can they should be changing in elevation, and what we're going to see is none. And he's going to go through how he did all of that and break it down. It's just pretty simple trig functions. And then if you have any questions during it, you can pause it, or just tell me when to pause and I can answer them.
So just is your position though that we can tell the shape of the ground with lights in the sky, or we cannot? Because you've heard from other flat earthers we cannot.
Yeah. So just watching the apparent position alone, nothing unique can be said. When you introduce occlusions, when you introduce terrestrial features like a mountain peak of a known elevation, you can start to make some determinations, because on a globe, the elevation of the mountain is going to be physically lower, which results in a different angle. And the whole system is derived from combining what we see with central angle theorem. So in other words, like, when, how you sometimes give the example of like, oh, well, the Earth's so big that, it just, like Home Depot type stuff and the curvature whatnot. Well, that's actually not true, because if at the distances that we're using for the cell Theo, what we found is that the description of how the stars move in the sky relative to an observer follows the full like what we call the full celestial drop, which I'll show you some diagrams here in a second for the angles and all that. But half of that angle is what they call drop over distance, and it's always half. So in order for that to be true, there can't be, this mountain can't also be a flat earth prediction. You know what I mean? Like there's mandatorily going to be a different angle produced out of this, because the half of the curvature, the other half of it, if you double it, tells you where the star's at. That can't be true if it doesn't work that way. So the rationale of like, well, it's just a Home Depot situation is not true. There's absolutely a mathematical difference between the two, and especially because angles equal time in celestial navigation, the difference in angles is equal to time.
You think that this actually is going to overtake things like the North Pole star moving 1 degree per 69 miles, something that's so simple that anybody can do, that anybody can verify, that everybody can prove for themselves? You think this method is going to overtake those things, or what? Because I don't see how you can think that the flat Earth is the truth unless it's going to answer questions. It should be like, things should be getting better because the flat Earth is coming out, right? Like if we should be improving on the globe's nonsense, and we should say, no, the globe is nonsense. So the flat Earth, now that we know the Earth's flat, here's how we're going to repair and fix things that are a problem. But the globe Earth it answers all questions. Just by saying sphere, it answers the upside down moon, the upside down sun, the backwards moving sun and backwards moving moon, and the backwards setting right to left in the south and left to right in the north. Everything is answered one simple word, sphere. However, in this world, it's way more convoluted. Everything you just said right now is more confusing than I've ever heard anything on the globe. ever.
Well, that's because you have a gross misunderstanding of the globe.
Well,
That's not
how is it
that's
gross if I
not
say we can
that's
place
not
two
my fault.
people?
Dude, your example was how is this going to take over 69 miles per degree? Like not even differentiating that we're talking a difference in true position versus apparent
No,
position, and that we
nothing.
see
I'm saying,
and that we see the same thing. So like
well, there's
how
simple explanations. There's simple understandings when it comes to the globe. Example being that anybody can right now take their angle to Polaris, figure it out, okay, whatever that is, then drive 69 miles north, and the North Star will pop up by 1 degree. So you do that
you
over
can
and
do
over
that
again.
you could do that on a flat Earth too, dog. It's the same. Like I don't like your
What do you mean?
examples
What?
means nothing
How could you do that on a flat Earth?
because we see in the same hemisphere of vision that the globe is using mapped as a sphere of a terrestrial sphere.
So it just happens to match then the 24901 globe.
Yep.
Okay, well, hold on a second. Now, on a globe Earth, what is the circumference of the equator? 24901, right? Or
Mhm.
thereabouts. Okay, on a flat Earth, what is the distance of an equator?
Same exact distance. It's the same exact thing.
That's
And when you
impossible. It's
it's this
impossible.
I know,
The
and when you do the triangle thing and multiply it
no
out,
triangle. What's the
I'm sorry,
difference? What's the
I'm
distance
sorry.
between the North Pole? What's the distance
Show,
between the North Pole and the equator?
show me the meme that you're talking about. It's the same as the radius of Earth.
There's no meme. I'm asking you what. Okay, North Pole to equator on the globe, I'll tell you, is 6,250 miles,
Same
6,250.
same
So,
exact distance.
okay,
It's all
then if the same exact distance, then that's the radius of a circle, and the radius of a circle at 2 pi r comes out to then the radius. Then it comes out to 39,000 miles. So the
Mhm.
equator on the flat Earth is 39,000, not 24,901.
Yep.
So there's no way that your 1 degree per mile would work because on the globe, that's 360 times 69 miles is exactly 24,901.
Yeah, that's a misapplication of the math, and I'll get the proper response for that here in a second.
Okay.
So we will definitely come back to that. Not running from it. I don't have the thing to address it, but I know exactly what you're talking about. That's why I said, because I've seen it in meme form, but it's not exactly correct. So we'll
Okay.
get to that. We'll get to that while or I'll look for that while we play this video. But
Yes.
So to reiterate, like this is the difference in true position versus apparent, and this is why I'm saying this is why my position is that we all see our own individual lights relative to us in our own dome of vision, because what we're going to see here is that the elevation change that's required as per the physicality given to us through the model presented as the globe doesn't actually occur as it should. So here we go.
Okay. Yes, and you'll press play. Go ahead.
Hello,
I don't hear
this
sound.
is amazing, and I'm going to present a new application for the celestial theodolite today. But first, let's recap what it is for those who don't know.
No. Did you hit with share? Share it with sound?
Oh, 1 second. Let me try again.
Yeah. And then what I'll tell everybody is after this video is done, I will look at super chats and answer those first batch, and then we'll go back to talking. So this way you don't have to wait till the very end. So just, in 13 minutes, we'll go over those. What happened to me?
I reshared it to see if I could get the audio to work. You're good. Let me know if you hear it.
The celestial theodolite uses observations of stars setting behind mountain peaks.
We hear nothing.
The exact second where the star.
What do you have that playing on? Can you send it to me on Telegram and I'll play it over here?
Yeah, I certainly can. Let me send you the YouTube link.
And it might be the same thing that you can't hear, but I'm sure you've heard it before. Oh, you're going to send me YouTube?
Yeah. All right, here you go. When you screen share it, I'll be able to hear the audio and stuff play through. So just play it through, and we'll just watch it on through you, vicariously or whatever.
Okay. Let me find where you're at here. Red Alan, YouTube. Come over there. Can you hear that or no? Did you hear that, Alan, or no? You didn't hear it, Alan? Okay. Well, you said you heard the sound, so we'll be fine. It's just everybody can hear it. And you said put it at 1.5 speed. Is that correct? Is that what you said?
Yeah, sorry. Yeah, just play it at 1.5, and then let me know when you hit play, and I'll hit play on my end so we can watch that.
Let me get this. And we're just looking at that. Trying to see what this is on the whole screen. Okay. I see what's going on. Okay. Let me put this over here. Sorry, we got to fix this for you. I think that's the whole video. What is this thing over here? Calculate sun height. Oh, okay, that's from the video. Okay.
Hello, this is Amazing, and I'm going to present a new application for the celestial theodolite today. But first, let's recap what it is for those who don't know. The celestial theodolite uses observations of stars setting behind mountain peaks. By noting the exact second where the star was no longer visible, you can then consult an astronomic almanac to determine the uncorrected angle to the star at the time, as in not influenced by refractive and other optical effects. By forming a right triangle at the base of the observed mountain with the other 2 points at the observer and the mountain peak, the geometric angle to the mountain can be easily calculated using basic trigonometry, where the angle is the arctangent of the height of the peak minus the height of the observer for this vertical distance divided by the ground distance, which is also going to be equal to the angle to the star from the almanac. It is interesting that the physical angle to the peak of the mountain comes out the same as the almanac angle to the star, despite there being no allowance for Earth curvature in the calculations. Most of the observations are done at long enough distances away that the amount of ground curvature would be significant. When the calculations are done using globe math, and that accounts for the curvature, the numbers are off by the amount of ground curvature present. Refraction, the bending of light due to the changing density of the atmosphere, has to be invoked to compensate for that difference, bringing it back to where it would be without the curvature. The following celestial theodolite measurements have been made to date, sorted by observation distance. The farthest one done so far has been to North Peak in Colorado, with a distance of 130,000 meters. But instead of discussing stars getting occluded behind mountain peaks today, let's try something new and completely shatter the current longest distance observation, which is going to be 7.7 million meters, which is 60 times the furthest record to date. And here's what we're discussing: solar eclipses. A total solar eclipse occurred on April 8th, 2024 in the United States, with totality lasting from 4:30 p.m. to 8 p.m. UTC time, and that was 4.5 minutes at any one given location. Noteworthy cities along the path are Austin, Texas, Dallas, Texas, Little Rock, Arkansas, Indianapolis, Indiana, Toledo, Ohio, and Rochester, New York. The path was going from the southwest to the northeast. And then, of course, the sun and moon are traveling from the east to the west. And the reason that the eclipse path travels from west to east is because the sun outpaces the moon, swinging the shadow around as it passes. The reason the path of the eclipse travels north is because the sun is getting farther away from the moon, making the angle of the shadow down to the ground more shallow and thus farther reaching. So now we've got to understand the eclipse. Where to begin? First, I want to understand why the path of the eclipse shadow would travel to the north. So the first thing to do is study the movement of the sun and moon in Stellarium, which is a planetarium app showing the position of the stars for a given location and time. Starting at the farthest point for the eclipse shadow, I drew a great circle route to the moon. Then at intervals of 1 nautical mile, which is 1/60th of a degree of longitude, I used Python to calculate the latitude and longitude coordinates for each of those interval points. I also recorded the observer's altitude angle to the sun and moon, which excludes refractive effects. And then I applied the angle versus ground distance for both the sun and the moon. So starting here with the sun, the first step is to create a linear trend line of the plotted data, which you can see is this dashed blue line. And the R value is high, indicating it's a good match, or close to 1 rather. The slope of the trend line gives rise over run, so the slope value of -9 e to the -6 has units of degrees per meter. Vertical is degrees and the horizontal is millions of meters. When we take the inverse, 111,000 meters per degree, and then divide by 1852, which gives us 60.038 nautical miles per degree. This is close to the expected 60 nautical miles per degree, where the sun drops by 1 degree for every 1 degree of distance traveled. Going back to this 111,000 meters per degree number, if we multiply by 360 degrees to get the circumference, and then divide by 2 pi, we get the radius value of 6.3 million meters. This is close to the 6371 radius for the Earth value, which is what we'd expect. But now when we go to the moon, something interesting happens. If we generate the trend line like before, this gives us 9.13 e to the -6 degrees per meter. Invert to get 109,000, and then when we divide by 1852, we get -59.1327 nautical miles per degree. Most unexpected. And then when you continue the math out, that results in a smaller radius value of 6.27 million meters. So putting this into perspective, when starting with the sun directly overhead and traveling 5,400 nautical miles, or 90 degrees longitude, the sun drops down to 0 degrees. For the moon, however, we only have to travel 5,300 nautical miles, which equates to 88.7 degrees longitude for the moon to drop down to 0 degrees. Putting it another way, if we see the sun as if it is traveling along a celestial sphere with the radius of the Earth, then we see the moon traveling along a similarly, slightly smaller celestial sphere. And that's what we're showing here with a side view of where the sun and moon appear as the observer increases the ground distance. So the scale is millions of meters, both directions. And with the sun, it's at the 6.3 million meters, the moon's 6.27. And then if we multiply by pi over 2, we get the base radius, which is 10 million meters for the sun and 9.8 million meters for the moon. So now that we have that background out of the way, we can actually analyze the data. And you can see here the path of the center of totality spanning across the US. And the data for the eclipse path is available as a Google Earth KML file from this NASA website. It tells us precisely where the center of the eclipse shadow is cast at a given time. There are 6,770 data points at 1 second intervals spanning from 6 p.m. to 7:45 p.m. for 112 total minutes. Next, the latitude-longitude coordinates for the ground positions of the Sun and Moon are needed over that time span. I wrote a Python script to extract this information using the AstroPy module. This allows us to calculate the distance along the ground from the observer at the eclipse shadow towards the Sun and Moon positions, giving us a base distance of our triangle. I also extracted the altitude measured in degrees of the Sun and Moon above the horizon for the observer, but these are for reference only. They represent an optical position in the sky, and we need to use the true physical position. The final measurement needed is the height of the object doing the occluding, which in this case is the height of the Moon. What we're going to do is assume the Moon is fixed at the 6.27 million meter height we found earlier, and assume it is only an optical effect that causes the apparent position of the Moon to drop in the sky as we get farther and farther away from it. The following table summarizes the known and unknown parameters. So first we have the center of the eclipse shadow, latitude and longitude, which we got from the data file from NASA. Then comes the observer elevation height, where we can take those lat-long coordinates and upload them to gpsvisualizer.com, which will export a CSV with the elevation data. Then the Sun and Moon ground position, latitude and longitude, which is generated in Python. We have the ground distance from observer to Sun and Moon, which is calculated using Haversine from those latitude and longitude coordinates. The height of the Sun and Moon is what we looked at earlier, and we're going to assume a fixed height over the observation period of 112 minutes. There's the observer angle to the Sun and Moon, which is generated in Python, but we're not going to use it because it is the apparent position. And then finally, the physical occluded angle from observer to Sun and Moon, which we don't know, but we can solve using basic trigonometry. Our assumptions are as follows. Number one, the Sun and Moon are at different fixed heights as they travel east to west. We'll consider any change in height negligible over the 112-minute observation window. Number two, assume the physical positions of the Sun and Moon are in a direct alignment with the position of the observer. That is, drawing a straight line from the observer to the physical location of the Sun is going to intersect the physical location of the Moon. Third, the light from the Sun to the Moon, and likewise the shadow from the Moon to the observer, is going to follow a straight path, where refractive effects of the light are negligible. Since we're using physical and not optical positions for the Sun and Moon, optical effects do not apply. And lastly, no corrections are going to be accounted for ground curvature. And here are the objectives of the analysis. Celestial theodolite calculations generally involve calculating the height of the mountain peak using a triangle of the physical geometry and then comparing to the known height in order to evaluate the measure of success. Lacking certain key measurement values forces a different tactic for this analysis. In this case, over 6,000 data points are available to analyze, so instead, success will be measured in regard to consistency across the full dataset.
Can you pause real quick, Alan? Just like next question.
Yep.
Oh, all right. Just real quick. So how did you figure out the heights of the Sun and Moon?
Good question. So doing rise over run using the length of the shadow and then the angle that we have for the observer viewing the Moon.
And you came up with 10 million meters?
Yep. The height of the celestial sphere. Which is
what, 62 something in miles?
Yep. Comes out to be the same ratio as if you did 1/10,000,000th of a terrestrial meridian or whatever. Like, so what that comes out, what that basically means is 6218 would be the, if you did it in nautical miles, I think it is what it comes out to. So it all comes out to be the same thing. So like earlier when I was talking about how.
Okay, but if it's all the same thing, then don't we need to have the distance between the North Pole and the equator be 6250?
Yes.
Okay, that's what it is on the globe.
That's
but
yeah, the globe is just constructed from a symmetrical coordinate system with the positions of the stars.
Okay, but you know how a circle works. So let's not play dumb. You know how a circle works. Hold on, let me just make sure, because you're making it sound like this is more difficult than it is. We know how a circle is, and we know how to get the circumference and the radius and everything from a circle. So if you think of the equator as a circle, the equator is a big circle. Okay, great. And the radius is going to be from the North Pole to that circle. So the radius of the flat Earth is 6250. So when you do 2 pi r, which is 6.28 times 6.28 times the 2 pi r's radius. Okay, so it's 6.28 times the 6250. Let me see what we get here, making sure I'm seeing this right. So if we go 6250 times 6.28, which is going to be the 2 pi.
39,000.
Right. So that's the equator. Yeah. That's the equator distance.
Yeah, that's because you're looking at a flattened out graticule and doing that. What I'm saying is that if you take out the latitude lines and multiply them out from the equator to the North Pole, it comes out to be 6210. You do the same thing for the South, it comes out to be the exact same thing. It's a symmetrical, right. It's a symmetrical coordinate system.
Or we live on a symmetrical land.
Yeah, well, if that were true, then there would be 4 million meters of deviation in the true positions of the sun and moon as this eclipse happens. Let's see what happens.
Wait, there'd be 4 meters in the difference of what?
There would be 4 million meters of change in elevation if what you're proposing about the ground being a globe is true. If it's not, then what's going to happen is these are going to travel parallel to the ground with no change.
Okay, but if somebody walked, then if that is the distance between the circumference of that circle is 39,250.
Jaron, we can it's calculated observer individual through the whole string. It never changes deviation based on the angle. It's always the same altitude. It makes congruent triangles, bro.
I don't know what you're saying.
Well,
But I'm saying something very simple. Anybody knows how to do the figure out a circle.
I get what you're saying, but also, right, there's going to be elevation change for these people. Regardless of these observers over the distance are going to start to show an elevation change when we calculate it out. The only way that wouldn't be the case is if they were just parallel to the sky the whole time.
All right, let's continue the video.
Because yeah, he's setting the stage for how he's deriving everything. Because like to answer the question, like how do you derive the altitude of the moon and the sun? Well, once we have the moon's altitude from the shadow length and the angle from the observers, what we can do is because the occlusion happens, we can derive what it would be for the sun under the same thing, making a congruent triangle. So as he's about to get to that to the juicy part here, he just had to lay the foundational groundwork.
Okay.
But can we consistently calculate the same height across all the data?
Press play whenever you're ready, sir.
I want to see what somebody wrote here. It says, Jaron, pi needs to be 2 for a 24,901 mile equator and a 6210 rate. Okay, so yeah, I mean, pi is not 2. So, all right, here we go.
Data points. These 6,000 data points aren't simply a similar measurement taken over and over again. Since the sun and moon are moving in the opposite direction as the eclipse shadow, the distance is constantly increasing from 2.6 million meters to 7.7 million meters, which is an increase by a factor of 3. Likewise, the altitude angle from the observer to moon drastically changes as well, going from 70 degrees down to 19 degrees, a change of 51 degrees. And then the azimuth to the moon sweeps out 140 degrees. The observer latitude changes 30 degrees, and the observer longitude changes 60 degrees. The observer elevation is fairly consistent except for this mountain range over Mexico. So the key parameters vary quite a bit over the dataset. Now let's get into the actual analysis. The first step is we're going to assume the height of the moon is fixed at the 6.27 million meters number we found in section 2. H moon equals 6.274 million meters. Step 2, calculate the occlusion angle using a right triangle where the base is equal to the ground distance from the observer to the moon and where the height is the moon height. So the occlusion angle becomes the arctangent of the height of the moon divided by the distance. Step 3, we're going to make another right triangle from the observer to the sun using the same occlusion angle from step 2. And since in a solar eclipse, the sun and moon are lined up with each other.
Just real quick, I just want to make sure, is he going to cover then,
is the same.
It seems to me that if we now know the height of the sun and the height of the moon away from the earth, then we can figure out whether or not it's supposed to change in angular size, right? So like, for instance,
bro, apparent thing that we all see individually. It's like what we see is not going to follow the rules of like a physical object moving away from you. That's nothing to do with this. You're kind of deviating from the significance of the fact that there should be a physical elevation change if the earth is a ball, but there's not.
Well, I just want to make sure that I know what, so we have to pretend that the sun and moon are not physical, that they are magical, but everything else that we see on the earth, a truck, a car, a building, those are real items.
Exactly. That's just like you have to believe that they're imaginarily changing physical elevation. Yeah, the exact same. Go ahead and press play. Continue.
Same as the angle from the observer to the sun. So now we're solving for the height of the sun, where our equation is height of the sun equals distance of the sun times tangent of that occlusion angle. And that's all there is to it. So now we just have to perform this calculation for all 6,700 data points and then calculate average and standard deviation values. The average comes out to 6,374,000 meters, which is very close to the 6,371,000 for the Earth radius. And then the standard deviation comes out to 6,200 meters, which is less than 0.1% of the average, which indicates the data is highly consistent. This is showing the height of the sun plotted out for all 6,000 data points, and the result is very flat. This is versus time. We can also show it versus distance. And the key point to consider here is we're actually starting the eclipse here, and the distance gets smaller and then gets bigger. So it's actually going over itself exactly, and it's so perfect you can't see it. So if you're thinking the reason it looks so flat is because the amount of globe curvature at this scale is negligible, then let's take a look. It most definitely is significant, which you can see here is 4 million meters at the end, which would be very significant compared to the 6 million meters of the sun height. And since we didn't have to account for it in the calculations, that is very telling. And then lastly, let's look at the physical angle versus apparent angle. There's a discrepancy between the physical angle that we calculated and the observed angle given by stellarium, even when it does not include refraction corrections. This disparity is shown below, which increases the lower the angle gets, similar to what we saw with the profiles of the celestial sphere. The sun and moon appear to be lower than their true physical position on account of optical influences. Here we can see the physical location of the moon is at 40 degrees, but the apparent is at 20. So there's a pretty big disparity there. And here's a spreadsheet showing the data. You've got the eclipse path, the sun, latitude, longitude, and distance calculations. Same for the moon. And then here's where I calculated the sun height. So you can see there's just a lot of data points here. And then you've got the average and standard deviation. So in conclusion, the relationship between the sun and moon during the total solar eclipse can be modeled out with very basic trigonometry while maintaining good consistency for the duration of the event. It is not necessary to make any corrections for ground curvature, nor to correct for refractive events diverting the path of the sun's light. This study does demonstrate that there's a difference in the physical position of where the sun and moon actually are located versus the apparent position where we think that we are seeing them due to optical effects. Even the globe model agrees on this point. This raises the question, is the ground beneath our feet curving, or is it the sky that appears to curve due to the nature of how our eyes perceive it, notably with the same radius value at which the Earth supposedly curves? I leave it as an exercise to the viewer to draw their own conclusions, but this only scratches the surface, and there's so much more to explore. And then let's briefly go over some things I have here in the appendix. So if you're wondering about moon height over time, here it is mapped out for 2 months. With the eclipse happening here at April 8th.
About one part of that. Something about the same radius or something. Let me read that again.
Oh, yeah. So that 6218 value that we were talking about earlier, you derive that same thing off of the altitude of the moon and sun, the constancy of it. Anyway.
6218, right. So he's saying that is the same. Should I read that part again? Where do you say right here? Okay. So it's how our eyes perceive it, notably with the same radius value at which the Earth supposedly curves. But the radius value of the Earth curving is 3959, not 6250.
Oh, that's in miles and what he's talking about is in kilometers. It's the same value, and then one might be in nautical miles versus statute miles, but what we're talking about is the exact same thing. It's identical.
Oh, so confusing. So you're talking about, so the 6250 he's been talking about the whole time is kilometers?
Yes.
Not miles?
Yes, which comes out to 3959 for miles.
Okay.
All right, we've been doing everything in meters. Do we completely abandon the... Anyway.
Don't do that. It's the only thing I know.
Yeah, it's a rough transition. But yeah, anyway, whenever you're ready to continue.
Yeah.
Here in the appendix. So if you're wondering about moon height over time, here it is mapped out for 2 months with the eclipse happening here at April 8th. And it is changing by about 10,000 meters over that duration. If we zoom into the period of the actual eclipse, you can see it's going from 535 to 570. So it's less than 40 meters change, so not very significant. And when I plug the numbers in with the varying moon height, the average number for the sun height only decreases by 1 meter, and the standard deviation decreases by 10 meters, so it's not that significant of a change. And then earlier we were talking about the 88.7 degree longitude change.
Oh, yo,
the moon
pause
to
for
go
a
directly
second.
overhead to drop down to 0 degrees. So here we have an observer directly under the moon.
Oh, yeah, I misspoke. This is in miles. It's 6210 miles, and then 3959 miles for radius. My bad.
But it said at the same rate that the Earth is curving.
Yes.
So the Earth curves it.
Yeah.
Radius.
So let me. I sent you a GIF to look at that has like the math equivalent for what we're talking about for that.
Oh, on Telegram.
Yeah.
Okay. I'll press that.
Yep. All right. Sorry about that.
At point A, and then at point B is that 88.7 degree longitude difference, showing what it would look like on the globe model. And since we have a right triangle here at point B, it's just a matter of taking the cosine of the adjacent divided by the hypotenuse. So you can see the math here. and it comes out to 275 million meters. Now we're told that the moon is 350 to 400 million meters here in this range, and what we're getting falls a bit short. And then lastly, you might be wondering how you could solve this same process on the globe, where you're solving for the sun height. And it's very similar, but you have different triangles. And then in this case, you're actually accounting for the Earth curvature. But the problem occurs when you have any triangle, the sum of its three sides has to equal 180 degrees exactly. And so if I assume the minimum distance to the moon of 350 million meters, what happens is this distance to the sun angle and the observer angle, those two alone add up to more than 180 degrees, so it's not possible to make a valid triangle, and it doesn't work.
All right, so what happened there in the analysis was the difference between what Stellarium shows in regards to how the sun and moon and the celestial bodies, follow that 69 mile per degree relationship. For the sun, it comes out to be if you were standing at the equator at 0 degrees and you were looking out at the sun being at 89 degrees, it would almost be right at the horizon, right? And then the moon would be 88 point something degrees. And when you trig everything out, you get a distance based off of that, like a physical elevation for it. And what he's saying here is that the distance that he derives using, the stellarium and the occlusions, which is what the globe is supposed to be predicated on. And when you compare that to what they say the actual distance is for, for Kepler's laws in Newtonian dynamics, which is you can derive Newtonian from Kepler and vice versa. So they have to give the same physical distance. He's saying that those distances don't match up to make the congruent triangle to have the eclipse happen the way that we see it. It would be off by a little bit. Now it's possible that they could introduce refraction to correct that or whatever a little bit, I suppose. But what he just pointed out there was the difference between the plane trig using celestial navigation tools versus comparing it to the physical distance that they know that the moon is because of Kepler's laws and Newtonian dynamics and all that.
Okay. And I'll just show what I was talking about real quick so we can move past that. So what I'm saying, and then I guess we'll read the super chats after, but I'm just pointing out that this here is a, let's go with a little bigger, this one.
Here's an easy one for you. I sent it to you on Telegram. Okay. You can see it. It's got all the math on it already.
Well, so here's the equator, right? And on a globe, we know that that's 24,901. But on this flat Earth, if we put it on a flat Earth, well, now the radius of that is 6,250, right? So, oops, sorry, it shouldn't be. Where's my dash? Turn that off. Okay, so that's 6,250. So then we can do the math on it. It comes out to 39,000. So I'm just saying that that's a problem because we can do. We know what the Great Circle route is all around the Earth, meaning any place that you're at, it's 24,901 miles to get back to where you are. So you can go north because that's where our longitude lines are, which makes more sense to use those. So if you went north and south, then for every 69 miles, the sun, or you can use the pole stars, are going to move up by 1 degree. So then how could that be the same on a flat Earth if the distance is different? Clearly, going from the equator to the North Pole on a globe would be 6,250, right?
Yeah.
So
the answer to your question is you have to know what the tool that you're looking at is representing. When the Gleason's map is flattening out curved lines to make them straight, that's it's still representing the same thing. Like it's still representing the same symmetrical things when it's outside of the equator as well. That's why what I'm saying that it's based on two hemispheres of vision merged together. Okay. So let's talk. So when you multiply out those lines, it comes out to be the same thing on both sides. It's symmetrical. You say it's because of a globe. I say it's because of a symmetrical coordinate system.
Okay, so tell me then let's go to the ground. Let's go to the ground and get out of the sky. So if we go to the ground with, I'm bringing up Google Earth here. Sorry, it's just going to take me a second. I don't know why I blocked you. I had to bring it over here. So if we look at lines of longitude in the south, so let's go here. So isn't this the AE map, the azimuthal equidistant, is everything's equidistant from the North Pole, right? So if we were to take this here and go down to, say, Punta Arenas at 53 degrees south, is that not the distance on the flat Earth as well?
Same exact distance. It's referencing
Okay.
the same exact longitude system.
Gotcha. Okay, so we're going to save that. So that's 9,000, just so we know, 9,837 miles. Okay, so we just drew that line there. We're going to hit save. All right, so now we got that. Now, if we take, again, what the radius of that circle is, which would be, again, 6.28 times that number, what I said here, which was 9,837. So times 9,837 equals 61,776. Okay, so we can divide that by 360 to get the amount of miles per degree. So when we do that, it comes out to 171. Okay, now let's go down here and actually measure it and see what it is on the Earth, because 171 would be a flat Earth result. So let's go down here and see what we get. So we're now measuring a distance between 1 degree of longitude. Let me see if I can see them. So there's 70 point, let me get it down to where it's easier to see them. So there's 71.3 to 70.3, right? So we're going 71 to 70, and that distance is 40 miles. So the flat Earth predicts 171 miles. The globe Earth predicts 40. And what do you want to bet if we go down there and measure it? What do you think we'll get?
You'll get the symmetrical value for the coordinate system which it's using. Like you're again doing it incorrectly and then concluding that the distance would be different when you're using.
Wait, how am I doing it incorrectly?
Projecting the same thing, because the method of determining the distance from any southern point on the North Pole to using 2 pi to get the miles per degree just makes huge circles, and to determine the distance on a flat Earth, that's what you guys think. That's how you guys think it works.
This is all I did was I figured out what the circle is. I'm sorry, this is not a circle.
We're using the same coordinate system. It literally can't be different. It's referencing the stars.
It literally can, because one of them reconvene on the globe. The lines of longitude get back together at the South Pole. So what do you mean that wouldn't be different? This one here shows the lines of longitude go to the very outskirts and keep expanding. On the globe Earth, they converge. They're very different. And so, yeah, in the north where we all live, it actually makes the flat Earth make sense. That's why going to the south changed my mind. That's why going to the south should change everybody's mind. If anybody goes down there and watches the damn sunset, you're going to realize, oops, this map cannot be right at all. It's so wrong, it's ridiculous. And one of those examples is we just went to 53 degrees south here, and we calculated the distance of this circle. And then we divided by 360, which is how you'd get the degrees per degree. And it's 4 times off. That means that as a plane left here, if a plane left here and went to fly across this ocean, it's going to have to go 4 times further than the globe says.
Bro, respectfully, that's a misrepresentation of how to use this coordinate system. You don't even draw straight lines.
Oh, so this is not a map.
A curve on that map is the same is the same length in the south as it is in the north, although it visually looks bigger because it's projected out.
That's impossible.
It's literally, bro, it's math. It's the same exact thing.
Hold on a second. So if 2 people are standing next to each other near the South Pole, they would be next to each other. According to this map, you would have one person here and one person here, and they would be next to each other. Those 2 people are standing next to each other. So is this person standing next to them. This person standing, they're next to each other. They can hold hands. They can hold hands, dude.
Yeah.
Wake up.
No way. Are they referencing the same coordinate system that's derived from single observer observations?
Hold on a second. If these people standing out here can hold hands,
it's not going to be a different number.
Hold on.
Are there other people out there holding hands?
Dude, if the people out here are holding hands, this is where they would stand, and they're holding hands.
Are there people out there holding hands?
That's if people stood around the South Pole and held hands, that's what they would do. That's where you would plot them.
So listen.
So I'm confused real quick. Is you saying this is a map or not a map?
I'm saying that when you're talking about a distance being different in the south based off of how it looks in the north, I'm saying if you're using a latitude and longitude coordinate system, there's no difference. It will visually look like a longer difference, but you could take the same exact distance in the north, transpose it in the south. It's just a math function. It looks bigger. It looks like it's a bigger thing because it's projected out and stretched out. That's a function.
And you're right.
It's not physically a different distance when referencing the coordinate system.
But all the lines of longitude converge on the north, so they must do the same in the south then.
Yeah.
But they expand. So the
You're
reason they
looking
do
at a projection, Jaron.
Right, it's a projection of a globe.
It's a projection of a coordinate system of two hemispheres merged together. We just went over the ground curvature that
and
would,
so the way
that would
we
be
could tell,
required to
but we
substantiate if
so
it's actually a globe, and there's 4 million miles of no curvature, bro.
man, it's just you're
Like,
not getting it. That these people around the North Pole could stand together and hold hands, and they would actually be touching hands. In the South Pole, the same thing is true, but on this map, it's these people are completely separated from each other. So to bring it back to reality means we have to bend that outside back to a ball. You grab it and wrap it around there, and you'd be back to where the reality is.
Show me your hand holding party, and I just showed you that there's no curvature for 7 million meters.
Yeah, well, you showed me that there's no change in the height of the sun off the Earth, which I wouldn't expect one. It'd be like you looking at an airplane and saying, hey, that plane that's flying 35,000 feet the whole time is flying flat. No, it's not. It's flying over the globe. It's staying the same distance from the ground.
Then how do the stars and sun set, bro? The whole model's predicated on the physical elevation change. That's why the congruent triangles for the celestial theodolite shouldn't be possible. That's why what he showed with the eclipse stuff, there should be a giant arc for both of them. Let me show you this real quick, dude. We have it simulated out to scale.
Oh, I just want to. I did say I would read super chats and I didn't get to that. But my point is that we can. So we have to be able to test what somebody tells me the Earth is. Okay. So if somebody tells me that the Earth is flat, and I say, okay, what is it laid out like? Are you saying that there is no answer to that, or is it laid out kind of like this? The real Earth that we live on. I'm not asking for sky coordinates or anything. I'm just saying the real Earth that we live on. Is it, if we were to get above it and look down, would it look like
probably geographically looks something like that. The coordinate system that we use, though, does not represent that.
Right. But because the coordinate system that we use wraps around to the bottom of a ball, meaning that this location is the same for everybody out here.
Jared,
that's our coordinate system, right? No, I'm asking you
respectfully, though. Think about this: if it wraps under a ball, right, there's going to be a physical elevation changes in the true positions of the bodies, and that's never present. That's what we just substantiated. So, however it works, falsification is independent of replacement, and that's the sentiment that you previously agreed with not so long ago. So I don't know.
I do agree with it. So if you are able to refute the globe in a way that has no answer. How? I just gave you the answer.
No, your answer conflicts with how stars set. Like think it through. Somehow they all stay the same elevate. Like, bro, regardless of the angle that they're viewing it with, he derived the same elevation. So it should actually be a different angle going down following the celestial sphere. If you can see the screen share that I'm showing.
Well, you're saying for one person, let me just ask you. So you're talking if a globe guy. Hold on. What are you showing?
Okay, I'm showing a simulator of what
Where are you showing? I'm talking about. What are you looking? What are we?
I'm sorry.
Oh, sorry.
Yeah,
I see.
Sharing real quick.
Sorry, I thought you were talking about there. Okay, got you.
Yeah. So look at this. On the top here, we have flat Earth. On the bottom here, we have globe Earth. The celestial bodies changing in elevation following the celestial sphere is how this should work for an eclipse. These two bodies should be changing in physical elevation relative to each observer as we calculated. There should be a change in this physical elevation. But what actually happened for each person, right, regardless of the angle, came out to be the same elevation every time. That's what he was talking about when he said we're going to have to look for consistency across the data set for the elevations, because we don't know what the elevation should be, but can we calculate the same elevation? For all observers, for all 6,200 some data points, this is the end result of this, that they travel parallel to the ground. There is no answer for this on the globe. The whole globe is built on this happening. They tell us this is happening. Before the celestial theodolite,
what do you mean, what's happening? You just keep saying words. So what do they say the globe is? Nobody says we live in the middle of the globe.
For the globe, okay. For the globe,
I know that's where they take the observations, because it's the same thing. But okay, nobody's saying we live there.
The physical elevation change is represented by this. So you're on a globe.
Represented by what? That little dot?
This is the celestial sphere for the globe.
Okay, but how would I know that? How would I know you're not showing me the Earth?
I'm trying to tell you that right now.
Okay.
I'm telling you that right now. It's labeled globe Earth right here. But anyway, I know it's really small. But anyway,
so you're talking about hold on. So that blue circle is the celestial dome, or the blue circle is the Earth?
The celestial sphere.
Okay, got you.
Okay. So
and then you have somebody on the top of it. What's that person up at the top doing? What's that line?
The person on the top. This is a separate thing. This is for flat. This is for flat Earth. This is what an observer would see, just on the surface of the Earth.
Got you. So he's sitting there flat Earth, and then as the thing moves away from him, it is changing height, right?
Well, the apparent positions, as they're mapped out, they appear to be changing height, but the actual elevation that's derived comes out to be almost no change.
But not from the same location. I mean, because you agree that the sun is moving away from you, right? So how could it stay the same distance from every person? If I'm looking at it and it's moving away from me, hold on. If you're talking about at the top is the flat Earth, so that person, isn't that sun changing distance for that person?
Yes, apparent.
Okay, but you're saying it doesn't really change position. It's the same height all the time.
It doesn't change in elevation. Yeah, correct. We perceive it arc and go down. Like we perceive this, right? And the globe also says that this is physical, but this is actually what was measured and what was plotted out and what happened.
I thought you said it measured the same distance at all times. It can't. You're looking right there. We can see it change distance.
The same altitude. Every observer
it's changing. We can see it changing. We can see it changing.
And it's the same altitude for every observer, bro. That's why it stays.
We can see it changing.
Where are you seeing it change?
Okay, so watch when it starts moving here. So that's going to be a certain height away from that person. Now as it moves, it changes height. That's changing. It has to change height right now. It's moving far away from him. I don't get how you don't understand this. If that you're telling me that light up there is staying the same height from the people on the Earth.
Yes.
Observer. Okay.
Always.
So, okay, but on this example you're showing of a flat Earth, it doesn't do that. You're moving it away and it's changing height away from the person on the Earth. Look at it grow. Now it's going to shrink.
Yeah. Did you see the scale of the change? It changes by like 10,000 meters. Like there's almost no deviation here. They consistently produce the same height for every observer over the 6,000 data points down to 0.01 of a change in deviation.
At the same time or at different times?
Different times throughout the whole course of the thing.
Right. So it's just basically calculating that for each person on the Earth, the sun and moon are always the same height above them. If you wait until it's above them.
Dude.
You're not explaining this well, though. You're not explaining. If you explain it like I'm a beginner, then, because what you're saying is not making sense. If you're saying that on a flat Earth that the sun and moon stay the same distance away from an observer when it moves away from you, is that what you're saying?
No, man. I'm sorry.
Okay.
It's calculating it for every observer across the whole path length of 7 million meters.
Right.
What every observer would see. And what it comes out to is that it doesn't change in elevation.
Okay, so wouldn't we get the same answer if we looked at an airplane?
No.
An airplane flying at 35,000 feet that is flying, and you took its distance away from anybody standing on the Earth at any time, then everybody would get the same height. The plane is flying 62,000 feet or 32,000 feet above them.
You would get different elevations.
How? If you're, that's what I'm asking.
Because it has different angles.
Because
it's
moving.
It's a function of the rise and the run to it. So all we're doing here is changing the distance and angle, and it comes out to be the same elevation every time.
Right. So if we did the same thing with an airplane, why would it change? Because the airplane is also going at the same distance above the ground the whole time. So that's why I guess I don't understand what you're trying to point out here. Because if I would expect what you're saying is happening, I expect that. That's all. I don't expect the sun to change height per person.
You're expecting the wrong outcome because the whole model is built upon the physical elevation change of it. That's why there should be no relationship between like the occlusions when we're doing the mountain peaks and stuff. There should be no relationship with the peak at that elevation for the occlusion for the observer. It has to change. That's the whole purpose of it. That's what creates the curvature for it to exist as. Like that's what the whole model is built upon. The drop over distance, if you double that comes out to be how much the physical elevation change occurs in the star. Like that's literally the whole model. That's what we're testing here. That's the purpose of this. Let me show you this diagram real quick to try and make it apparent here. And then
anything that can be explained should be able to be explained easily if you have a grasp of it. So I would think if you have a grasp of this, you'd be able to treat it like I'm a second grader, fourth grader, and you explain it to me. So far, you're just saying a lot of words and then bringing up different graphs. That's not really teaching me anything. It's not showing me what is actually happening. Like if you were really trying to show me, you'd show me here on the Earth, if this person stands here, he measures this distance, and this person stands here, he measures this distance. You're saying it always is the same distance, but then you're showing on your graph the distance change. That's what I'm saying. As that line moves away from you, that
is the elevation of this changing as the distance changes? Because that's what's supposed to change.
The elevation from the circle down below?
No, from right here, from anywhere. Because this is okay. This is what was
You're talking about the elevation angle or distance? What are you talking about?
Okay, you see the sun going left.
Sun and
to
moon,
right
I see
here.
it there.
Okay.
Yes.
These are supposed to physically change in elevation and arc down, like this. This is what's supposed to happen on a globe. When you plot this out when you plot this out for every observer, you're going to get a physical. You would get a physical elevation change over the distance. That's what would create ground curvature. That's the graphs that he was showing where it didn't do that and all that. This is a 2-scale simulator showing all the data points plotted out and what it would look like if it's following the curvature of Earth versus what was just plotted out with no elevation change. The distance is changing as this moves, but the elevation remains the same. Each observers absolutely cannot derive the same elevation on a globe. It would have to follow this. The whole model is based on this.
I mean, maybe I'm the one that's not getting it. I don't know if people in the chat get it, but let me look at the super chats real quick and we can come back to this because I am not grasping what we're looking at here. Still, I don't know why the line's coming from the middle. I do understand that you're saying from a globe, this is what you would expect to see, but that line is staying the same distance from the person at the middle, right?
No, you see how it's physically changing in elevation though? You see how it's
staying the same distance from the person in the middle, correct?
Yeah.
Okay, so I'm just saying that that's staying the same distance from the person in the middle, and it's on a curved path, and it's going down away from that person. And now you're putting them up,
and it's showing the physical elevation change. This is what would happen if there was curvature for this to change on. But this is what was measured. This is what was plotted out and measured.
But we know that the sun's going to end up on the other side of the Earth 12 hours later. On that model that you just drew, it's just going to keep going out forever, right?
Bro.
Well, just saying that it seems
like
to me what you're doing is you're conflating both models. You're saying you're putting one model and then saying, oh, this would work on a globe, and that is what we see. And then you say, oh, but it's not what we measure. We measure this angle not changing, right? In which case you're saying on a flat Earth that the sun and moon are just moving like that away from you.
Yes,
right, like this line that you drew up here.
Yes, the objects that we see, how they arc and get lower in the horizon.
Okay, so the distance then to the ground is changing.
That's just how we perceive them.
Okay, but the distance to the ground is changing, and we can figure out what the amount that it would change in angular size. If you're telling me we now know the distance to the sun and moon on a flat Earth, then I can calculate what the change in their angular size is.
You're conflating models. You're conflating Newtonian concepts.
Let's just go to just flat Earth. Let's go back to when I'm a flat earther. I'm a flat earther now. I believe in the flat Earth. Okay,
great.
You're now telling me that we can calculate the sun and the moon distance from the Earth. That's what you're saying. From the flat Earth.
I'm telling you, that's what the trig comes out to based on the occlusions. It's rise over run. Yes.
So we are accepting the trig, but if we look at the angular size change that is expected, we're not going to see it.
If you're assuming the sun is a physical body that you're seeing, and it's not.
Well, that's what you're assuming. You're assuming that.
How so?
Because you just told me that the distance doesn't change and the altitude doesn't change. So how are we getting altitude and distances to things that aren't physical items?
Bro, it's a calculated value based off of occlusions. Like,
right. And so if you calculate the value and it comes out,
saying the occlusion doesn't happen.
So really, this is what we have to do. We have to believe that the sun and moon are magical. That's what we have to believe.
No,
well,
not really.
They're not. Are they physical or are they magic? Or are they apparent? Or are they pretend?
They're apparent in both models, and the elevation change is apparent too. That's what I'm trying to tell you.
Okay. Because
whatever source of light these are, whatever source of light that is, we don't see the true thing. We only see what is in our hemisphere of vision. That's what this whole thing is plotted out against. This is what this is how the whole thing works. And when they say, okay, we have the true position, which is just the zenith measurement of where it was, and then they add 15 degrees per hour to it, they're like, okay, it's following ball curve. As it's getting lower in the horizon, that means it's physically getting lower. They even attribute negative coordinates to it and say now it's below the ball. This can't be below a ball if it's also in reality physically still above us.
Okay, then it would never set.
I mean, if you impose conditions on it where light propagates infinitely.
Well, I mean, that's okay. Well, so you're saying, yeah, you want to go with light attenuation and it's not infinite light. Okay, I'll give you that. I even think that might be the case anyway. So, but I don't understand how I'm supposed to just give up on the ideas of things changing angular size if we know their distance, right? Like I never could say that as a flat earther. I couldn't say I knew the distance of the sun because it didn't work out from 3 observers.
Right.
It only worked out from 1 observer.
Right,
Or 2,
dude.
I mean.
And that's exactly how the whole model was based, bro. It's a two-party celestial navigation system. Like that's what the part of there was like a royal decree in 1777 where they were giving a financial reward for people that could make the coordinate system work in the way that you just described it for 2 people. The whole idea of like drawing triangles to the sun for 93 million miles and all this stuff, all that is supplemental. If you want to actually like use the globe so-called and like do celestial navigation, all of it changes the all the distances are assumed to be the same. They just make an equidistant web. And what we're showing here is that there's no elevation change in the way that they say that there should be.
So let's say that this was happening and the stars were out, right? So the stars are moving with it. So you're saying that everything then moves parallel to the ground? The stars don't move either? Because they follow the same paths.
No, they follow the same path, but it's apparent. The actual elevation isn't changing lower. That's why they get occluded by mountains at elevations that don't change.
Right. And so do the sun and moon, right?
Apparently, yeah.
They get occluded by mountains. I mean, that's what the sunset would be.
Oh, yeah.
Correct?
Sorry. I thought you were talking about the eclipse data. Yeah. Yes.
Okay. So I'm just trying to say, so then you're saying that all the stars never actually go lower. They just are staying the same height above the person on a flat earth at all times. As they move away, the altitude stays the same.
Correct. The actual source of the light is physically staying the same altitude, even though it's being plotted on a coordinate system that says that it should be changing in elevation physically.
So then that means that the light of stars is much greater than the sun, because they're also staying the same height away from me, and that I can see the starlight way after the sun is gone. So that means that the sun is not as powerful as the stars in the flat earth model.
Bro.
Okay, listen, if you're saying, hold on a second, just imagine that we're looking at the sky and the sun and moon are moving in the sky. The stars move the same speed about. I know it's a degree off or something, right? But they all move the same general speed. Correct?
Yeah.
Okay. So you're saying that the sun and moon don't change their the sun and moon don't change their altitude away from the person on the flat earth. So then neither do the stars.
And neither do the stars.
Okay. But if we watch the sun goes away and it sets.
The apparent sun sets, absolutely.
Okay. And then if I'm still looking in the sky, I would still see stars past it. Right? The sun sets, I can see those stars.
Yeah.
Okay. Just making sure that that's what you're saying, is that those stars must have a more powerful light than the sun, because the sun goes away, goes out. It diminishes, but the starlight we can see much further than that. Are the stars further than the sun? Let me put that. Maybe that's the problem.
No, bro, I have no idea how far they actually are in elevation, but what I'm telling you is that the source that we see, what we're basing this off of, comes out what the globe is, saying is true. We're representing it over a flat earth, and we're showing that the apparent angle changes are just apparent. They're not physically changing. That's a huge problem, because irrespective of the distance of the stars or the sun, they should change in elevation physically as per what the model dictates as a physical.
And is that the right height? The way is that scaled correctly?
Yes, this is to scale.
Okay, so go to the flat earth part at the top, and then put like a where an airplane would be above that person.
Oh, I can't edit this.
No, not edit it. I mean, just put your mouse there so I can see.
Okay. Gotcha.
So I don't know what the distance is. What is that distance between the ground flat earther and the sun and moon up there?
3 times 10 to the 6.
What? I don't know that math.
I don't know, like 3 million meters, let's just say.
I don't know meters either. Okay.
So let's just say 10,000 miles, and then so now I got the guy at 10,000 miles.
Okay, the plane's that close to the sun?
Bro, what?
I'm asking you to put your fucking mouse cursor where a plane would be above the person on the flat earth. It's not difficult what I'm saying. Put your mouse where the plane would be.
You just anywhere would be the plane.
No,
right?
where a plane flies about 30,000 feet. but I don't know your scale, so I can't tell you where to put it.
Okay. I got you. My bad. You said 2 scale. My bad. I thought it was just like anywhere we could just.
No, I want you to put it where the
I got
plane
you.
would be.
I got you.
Because if we, so go to 30,000 feet, whatever.
30,000 feet, 2 meters, 9,000. Okay. Where's the? Oh, my bad. Okay. So about 9,000 here. All right, here we go.
Okay, now zoom out so we can see kind of in reference to where that thing is. So that's 30,000 feet where your mouse is?
Yeah, thereabouts. Yep.
Okay, and then you're saying that so when we see out the window of a plane and the sun and moon are lower than the airplane, how does that work in this model?
That's just apparent, bro.
Okay, so I'm asking you how it works in this model. You're saying that perspective moves things lower than our eye position?
Yes. Sometimes people will see the sun in the clouds. It's just an optical illusion.
Oh, well, the sun is in the clouds because it's above your head.
No,
Nobody
I'm sorry.
sees it.
No, like, have you ever seen the video where they're like on the plane and they like show like almost what looks like the orb of the sun, like that's in a cloud?
Yeah, okay, that's not what I'm talking about. I'm talking about you can actually see the
like, look,
sun.
it's close. That's all just optical illusion stuff. And then,
But the sun and moon, we see them go below the plane, the airplane, below the plane. You can actually see,
it looks like it is apparently, but it's not.
Okay, but how about with like airplanes? We can see the bottom of airplanes lit up by the sun, which you can't see. Absolutely.
Okay.
Do you want me to show you? I mean, well, that tells you that the sun is lower than the airplane. The sun is lighting the bottom of the plane.
Show me your examples of plane lighting under the thing. But what I'm showing you right now is that there's no physical elevation change.
Right. So but the reason I brought this up is because then that would require that not to be possible to what I'm saying happens.
Dude,
right?
Light being reflected onto an airplane or whatever is going on with that. Like, you have to show me. I'm not familiar, but show me what you're talking about. And then, but what I'm showing you is that they're never changing in altitude. Now, if you do this same thing on a globe where you're traversing over a globe, right? With our,
I'm just trying to point out that there's evidence that the sun drops lower than your eye view many times, lower than airplanes. And if you're on a mountain, it drops lower than your eye view. It drops lower if you're on the beach, but that's hard to see because you're right at the water level. But
yeah, and that's always apparent.
Okay, so what I'm saying is, if it's apparent,
never physically higher than the sun.
Right. You are. I mean, that's what I'm saying. So if you're not physically higher than the sun, then how would sunlight hit the bottom of an airplane? Would it do that?
You have to show me what you're talking about specifically.
Get in there. 1 second. I don't know how far back it is in this. Let me find it if we can. Where is this? Where are we? Nope. I'll find it here in a second. Maybe somebody's here. Oh, there we go. Thank you. Share. And I know that Dave McKeegan did a whole video on it too. I was going to find this video though. Let me put this one in here. Telegram, save messages. I wonder if Dave's around. Save messages. Because I think if we can show then that there's evidence that obviously the sun does go down. All right, let me find it here. Oh, I know what I would look up. Let me look at this. This is it right here. Let me bring up his video of this. So yeah, this is right here. Let me see if this is it. Sorry. Okay. Sorry, my view that.
I can't hear the audio.
Oh. Let me try to bring it up for you. Go choose the sound. Can you just listen to this part on YouTube? Because I don't know how it's not picking up.
Yeah,
my
can you,
sound.
can you send me the
sorry.
link, and I'll play it real quick.
Wait, the link to my show or the link to this video?
Video.
Yes. I'll put it into Telegram. If I can find you. Oh, and there you are. Okay, here you go. That's that video. Yeah, just listen to. I'm actually. What time is this at? He's at. It's only 8:14 video, but just listen from 5. That's almost 6 minutes. You can listen from 6 minutes on, 6 to 8. So it's only 2 minutes you're gonna be listening to.
Okay.
And I'll play it for people here, just so you can hear the explanation here.
You didn't send the link yet.
What? I didn't send what? Sorry.
You didn't send the link yet.
I didn't hit enter. There you go. Sorry.
Hello everybody, hope you're doing well and thanks for joining us for what will be a relatively short video this week, because I'm also working
of the plane. The bottom of the plane is shadowed because the sun is still above the plane. Just like it's still above our plane, it's just moved far enough away to where we can't see it anymore. So Dave McKeegan's simple observation to debunk the flat earth is just ignorant.
Unfortunately for Joe, though, he's actually just perfectly demonstrated my claim. Now, to be clear, I never claimed that the sun is always visible on the underside of planes. It depends on multiple factors, like whether there are clouds blocking line of sight of the light from the sun to the plane, how far beyond the horizon the sun is and how high the plane is. If it's too early before sunrise or too long after sunset, then the sun might have already seen to be set for the people on the plane. If the plane is at lower altitudes, like the one in Joe's footage, then the sun will set sooner for them than if the plane were at 30,000 feet, and you only get the reflection when the plane is in line of sight between you and the sun. So if the plane is flying towards or away from you towards the direction of the sun, then this reflection can last a couple of minutes, whereas if the plane is flying perpendicular to you and the sun, then it's going to cut across that path pretty quickly. But the sun would never reflect off the underside of a plane on flat Earth, as Joe himself points out, because the sun would always be higher than the plane.
The bottom of the plane is shadowed because the sun is still above the plane.
So not seeing a reflection on the underside of one particular plane does not disprove my observation for the globe, but seeing the sun reflecting off the underside of any plane disproves the Earth being flat and the sun being higher than the plane. And eagle-eyed viewers may have noticed that as Joe zooms in his video, the underside of the plane lights up with a reflection of the sun. Someone actually commented about this on his video, but he tried to argue that that's not the case and that the light is reflecting off the top of the plane. Except here is a frame grab from Joe's video as the plane is lit up. And zooming in, that is clearly the underside of the plane. We can clearly make out the shape of the plane. I mean, the tail of the plane is a clear reference marker for where the top of it is, and yet the sunlight is on the opposite side, meaning the sunlight is reflecting off the underside of the plane. It seems quite ironic that Joe claims that
he does another video where he does some actual examples, but I'll show you one that somebody has that actually shows a better light underneath the plane. Because again, what he's saying is that Joe went and filmed one plane and said, look, there's no light underneath it, even though in his own film there was. But like Dave said, not seeing it one time is not evidence of anything. You'd have to, but yet seeing the light shine off the bottom of the plane is evidence that the sun must be lower. Because there's no example. Now you might go to clouds, but the difference between clouds is light shines through clouds and it doesn't shine through planes. So we would never have a case where light should be seen underneath a plane unless the sun is physically lower. But again,
we'd have to get some more information about the flight to determine like angle of the plane. Like this, was it turned a little bit? Others like where was it?
No, but regardless, how could it have the sun underneath it?
What was it flying over? Was it flying over the ocean or something? Like there's other factors to consider there. I wouldn't argue that seeing this reflection on the underside of a plane proves anything. It's apparent. Like the
not
sun,
apparent. How could it? You can't show anything that has light hitting the bottom of something that the physical light is above it.
Bro, you showed a video of a guy filming a thing. We don't even know what the plane was flying over, where it was, or what the if it was or we don't know the pitch or the yaw of it. Like there's a lot of other factors to consider to explain how a reflection happened on the bottom of a plane versus no altitude change over 7 million meters, dude.
I don't know about 7 million meters, but that's, again, I don't even know what that
It,
distance
it,
is.
it was the length of the shadow going across America.
Right. I guess what I'm confused about that is, again, don't you expect that? Let's say the Earth were a globe and you had people in California and New York. Would you not expect the sun and moon to be the same height for both people?
No, look at this right here where I'm zoomed in on what the globe
Where are
would
we
be.
looking? Hold on. Sorry. Now you have to tell me where we're looking.
Oh, sorry, I have to reshare. Give me 1 second. I think I have to reshare.
Let's see this.
StreamYard. Share. Entire screen. Let's see.
I've never seen this video about this.
So look,
Kind of
check
this
this out. You see how on the globe, as you get further out,
Well,
there's
let
a-
me bring it
there's-
up.
it starts to get lower. There's a deviation in altitude.
Oh, nobody can see what you're doing yet. Hold on.
Okay.
Okay, go ahead.
Okay.
We can see it now.
So as we start off on the globe, as we get further away, the curvature starts to become more apparent. You see how I'm scrolling out and this is starting to get thicker?
Yep.
Okay. So if we extended this out for 7 million meters, what we have here is a deviation from a plane elevation. So something has to, if something's following the curvature of Earth, as it's setting, then there's going to be an elevation change for the observers that are viewing it. You can't calculate the same elevation over the 7 million meter distance for everyone unless the object is actually also still parallel to the ground with no deviation. So when you say like you expect that, you expect the wrong outcome.
Okay. And you've seen before, like sunset where the mountain gets the light blast and things like that?
Yeah, tons of that. There's actually a good
Okay.
video of it right now I can bring up. It's just another instance of, like for example, if you're standing in the shadow, that's the way you'll see it. When you stand on top of the mountain, you see the same shadow going out to the horizon. It's just an optical illusion based on where you're standing. The shadow alone, based on where the observer is at, doesn't tell us anything really unique, except for it's been a minute since I looked into the shadow thing, but there's a whole bunch of stuff on that.
Let me do the super chats because I told people that and I'm lying now, so I don't want to lie. Okay, let me go to the super chats. I'll read you those real quick. Super chats. All right, so we got Dave's Waffle House. Thank you very much. 2 pounds says top man, big respect. JSS Tiger, $5 says, Alan, you don't do math. You don't have the right to present yourself as an expert on celestial mechanics.
Top of the clouds.
From Jesse, $5 says, Alan lied about the formulas, claimed to have a formula that worked, but would not give it to me. What he had previously given me didn't match reality. Any response to that?
Yeah, the formula that we gave has always been the same formula. They're published right here on the notation guide for the celestial theodolite. There's never been a different formula. Like, ask them for the different formulas. Like, I have no idea what.
So anybody can go to that page and they can get the formula and they can do that themselves.
Yeah, it's all based off of rise over run, and then there's a little bit of central angle theorem that we reference, but it's all straightforward. It's the most basic trig you could do.
Thank you. We've got Kango 4457. Thank you for the New Zealand dollar. Says, Alan, everything we see is apparent. It is a refracted pencil in a glass of water has real position. So the sun has a real position. Just say magic. It would be less embarrassing for you. The sun sets because of magic. Okay, we've got from Jesse, $5 says, if Alan won't debate me, just have me on and I'll show that he's deceiving people with the celestial theodolite BS. His results do not match reality. Okay, from Jesse again says, the flat earth model predicts whatever magic is needed to make the flat earth appear to measure like a globe, including sunlight bending 100 degrees. Well, more than that, 180 degrees really. From Jesse says, Alan lied about my CT measurement at 25 miles being indistinguishable for flat versus globe. He's previously agreed that 25 miles was sufficient distance. Okay. We've got Slitherly.
Yo, real quick, let's pause. Let's pause on that real quick.
Okay.
It's not about the distance. It's a ratio of a triangle. It's a combination of distance and elevation angle. So the mountain that he specifically went to and chose and made a simulator to see if it would work was like the lowest possible angle that you could get. And it's not about just the distance there. It's indistinguishable.
So it only a very small window that it works, or no, or it does work universally?
No, dude. The globe only exists as that ratio for the measurement. Like what he did specifically was went to where it would work out. Everywhere else that you go, where you're not trying to specifically fix the ratio to get it, it's not close to a globe.
Okay, so like if this were real, I just want to say something. If this were real, then there would be a way that people could go and verify this themselves. So there's an easy process to do this?
Bro, not
Oh,
only no, that's the actually you just reminded me of something. Not
Yes.
only is it repeatable and everyone else can do it, we're actually
Okay.
paying people to do it. Now
Okay.
we
I've seen
have
people
the
request that, but I didn't see anybody answer it.
yeah, we have the see I just put out the celestial bounty. So am I still screen sharing?
Yep.
So right here, if you could put this in the chat or put it in your Telegram as well,
It's on the screen. Go ahead.
forward it to people so that they know where to get it.
Okay.
We're offering up to we have a $300 pool, $50 per measurement. All you need to do is have the ability to record stars at night and make sure that
Mhm.
the peak that you're filming is distinguishable. So in the example here that we're looking at, you can see the star and you can see the outline of the peak. That's all you need to do. The quality can be a little less, but
Okay.
as long as it looks like that, you're good to go. All you need to do is write down your latitude and longitude coordinates of where you're recording from, the name of the peak, which you can get from a peak finder website or something similar. You could look it up so we can get the necessary information from that. And you
Okay.
just need to give us the timestamp for when you started the recording of your video so that we could math out what it would be in real time for the star's position and stuff. So we just need most recording devices will start the file name with the timestamp of when you recorded it. So if your device does that, you're already good to go. So
Okay.
that's all you need. Just record looking at a mountain and have the mountain in the center, obviously for the peak to make it easier and remove ambiguities, and that's it. And so in the South specifically, because we have a bounty going, so if we need some Southern Hemisphere observation. So if you live in the South, um, any distance, there's no like bad distance. It would be interesting to see what happens over a wide range of them. But what we found is that if you're about 5 miles away from a peak, there's not really any distinguishable distance. So preferably, if you could be 10 miles plus and do increments of 10 miles out, you could even use the same peak in the same night. So you could make $50 per video per star occlusion, so long as you're following the distance intervals.
Okay.
And
Thank
that's
you for
it.
that.
And then in the north, if you live in the north, if you live at sea level, we need some more sea level measurements. We were only able to get 2 of those, and so we need to get some more. So
Okay. We'll keep going with super chats. We've got where are we at here? Alan, we've read that one. Okay, so we got Slitherly says, "What's up, Jaron? How do you feel about our $50 vast bet for 2026 now that their tech demonstrator is now in orbit?" What? I don't know. I don't even remember making that bet, but it sounds like me. So I'll have to look into it. You said vast. So I said that vast wouldn't launch. Is that what it was? Or vast wouldn't go to space?
Oh, dude, I was gonna ask you about that too. So do you remember that guy you bet for the Artemis project? I think it was, or something.
No, it was for Dear Moon.
Oh yeah, did that guy ever pay you out or what? What
Nope.
happened with that?
No, he said he wasn't. Now the nice thing was that because MC Toon, I thought he was going to convince the guy to pay me, so MC Toon paid me the money and then said he'd get it from the other guy, and he has not paid MC Toon.
Oh wow.
So yeah,
well, at least shout out to Toon for covering that.
Yeah, shout out to Toon. Yeah, shout out to Toon for that. That was nice of him to cover that, because I would have just kept going after that guy and calling him a dirtbag, because he just basically said, "What's he going to do? I'm in a different country." Like, oh wow.
So Jaron, real quick in between super chats, let me show you this simulator that Jesse
Hold on,
made.
let me make sure on the screen.
So that he could
Oh, you
cherry
are.
pick an observation to fit the ratio needed where it's indistinguishable. So what he did here is, if you just move this slider here, right, when they become indistinguishable, this is where he went to go make his measurement. That doesn't, like, that's by definition cherry picking. Like all the measurements that we have are the ones that came from Mike originally. He lives in Colorado. There's mountains to his east and to his right, or there's mountains to his east and to his west. He just picks the ones that he could see. Kat and I got a sea star, did measurements. We did one in the parking lot of a Dollar General that was shut down. That was our closest measurement at 5 miles, and then we did another one that was like 49 miles. So there's a lot, like, building a simulator, looking for a spot where there's no difference, going and measuring it, and then concluding that it doesn't work, even though
I agree with you. That's not right way to do it. Okay.
Even though even though the emergence happened with our principles and all that, he's like, it's just a.
You're claiming that if we moved anywhere else, that the globe result would be worse off than the flat result.
It's like that everywhere.
Yeah, so I'm just getting you to verify that.
Yes.
Okay.
That is what the data shows.
Okay. We've got. Have you gone full redart? No, I don't know what you're talking about. I'm not going to argue things other than what I know to be the case, which is the shape of the Earth. So besides that, if you're talking about NASA missions and stuff, you're not going to catch me debating that. Human being, thank you very much for joining the club. Jesse says Kevin Samuel thinks Alan is good at math, but Alan can't recognize that the circumference of the equator cannot be 24,901 miles on a flat Earth. 2 pi r. Okay. Does Alan deny Haversine on Earth? Haversine allows for 4 equidistant positions on Earth, but it is impossible to have 4 equidistant points on a plane.
What equipositions are built that function as that? Like, that's not even, like, calculatively, that's true. But what even functions off of that? There's literally like nothing.
But on a globe, could you not have 4 equidistant points?
Yeah, no, for sure. And then also regarding but I'm saying, like, what terrestrial features and what part of engineering is predicated on doing that? There's nothing.
The Haversine, though, isn't it?
No, that's not what the Haversine does. The Haversine calculates distances between a spherical coordinate system. It uses the radius.
Yeah, I know that, but doesn't it use the 4 equidistant positions to come up with that formula?
Not that I'm aware of. All you enter is your latitude and longitude, and it does like the cosine between it. So I'm not sure.
I'm not sure about that either. I thought that that's what it used, but I don't know. All right. We've got Alan. Are lines of solar noon and lines of longitude straight? How can they converge going southward and northward of equator if they are straight? Wait, hold on. Are lines of solar noon, okay, gotcha, and lines of longitude straight? Well, yes. How can they converge going southward and northward of the equator if they are straight? Oh, I see what you're saying. I don't know. You don't have an answer for that. Do you? I mean,
is he talking about how the lines of longitude are flat on a Gleason's versus curved on a globe projection?
No, but he's saying lines of solar noon. So if we drew a line of solar noon from everywhere that's seeing the sun, so say it's the equinox, and we draw a line of solar noon, then they converge going southward and northward of the equator, but they're straight. On a flat Earth, they're just straight lines, but on a globe Earth, they would have to come back around and meet, right? South Pole or wherever. We got, what is this person? OMF Glows? I don't know what that is. OMFGOLLZ. I think Alan's model is consistent, but he needs to bite the bullet that people at the South Pole could hold hands and be mapped on opposite sides. Well, yeah, I think he gets that's, so what he said is show me the people holding hands. Now, again, I don't know. That wouldn't convince him.
I basically showed a series of people holding hands, showing that there's no curvature. And then, like, your proposition was they could hold hands if they, if they were there or whatever. So, like, that's why I said, well, show me what you're talking about, because I can show you what I'm talking about.
What I mean is that people who went to the South Pole, they start from 3 different locations, right? Like, you can get to these.
No, I got you.
Okay. Just making sure, because there's no such place on that flat map that works. Like here, you can't have, we have a South Pole somewhere on the Earth. And let's just say that it's what we used to call it as a flat earther. It's a ceremonial South Pole, right? So they've got some place that they mark in the ice and they call it the South Pole, somewhere on this map. Now, this person can get there in 5 hours. This person can get there in 6 hours, and this person can get there in 7 hours, but they're the same place. So you now need to find a place on this map that we can draw a location, let's say here, and say, now, can those people get there? Can this person get there in 5 hours? Maybe. Can this person get there in 6? Never. Can this person get there in 7? Never. So you're going to have a problem with, we know that the South Pole exists. I know that it exists because I've seen the South Celestial Pole. So what else would be below it? I mean, you'd have to now invent something that doesn't make any sense. I saw it. We were here. Where were we? Here. And it was about like in this area, the South Celestial Pole. And when we flew to Union Glacier, it'd be out here somewhere. Okay. So this is the South Celestial Pole. Below it is the South Pole. Now I knew that by going in that direction, whenever the sun was at its lowest, so say the sun's coming around here, and it's at its lowest at 15 degrees. If I walk towards that, the sun's going to rise up by 1 degree every 69 miles. So the same thing is true no matter where these people are here. We're all at the same longitude. So we're all at 80 degrees south right here, right? So, or let's say we're here at 53 looking at the South Celestial Pole. That means somebody here at 53, somebody here at 53, somebody here at 53 are all going to be looking up into the sky, and they're going to see the South Celestial Pole, and they're going to know the South Pole's below them. So they could all walk in that direction. Yet on this map, it's all opposite each other. we'd be going this way. And yet we would meet in a very short time at the South Pole. That's how they found the South Pole. So this tells you that this map can't be right because this has people going in opposite directions. Where on the globe Earth, they meet at a point, and that's what happens in reality. And anybody could say, oh, Jaron, you don't know that for sure. Okay, what that would take is that you would have to have a world where somehow they knew that at Union Glacier, it matches perfectly the globe model, meaning that when we flew out here, they knew, well, let's say we're at Union Glacier, they knew that right there, they're like, yes, they would only be 600 miles from the pole, but it's really, much, much more from somebody over here at the same longitude or the same latitude. And somebody over here at the same, no, it's the same for everybody. If everybody is at where we were, 80 degrees, they would all see the sun do the exact same thing, 15 degrees in the low, 35 in the high, if it was the same date. They would all see that. And if we all walk towards the southern part of the sun, it would be in the same direction. Yet on this map, it's the opposite direction. The lowest part of the sun is going to be here for this person, here for this person, here for this person. So they'd all be walking there. This guy would walk here, and this guy would walk here, and yet they would all meet. So, I mean, it just tells you that the Earth cannot be this map. It has to be the globe because that's the only way that reality works. And again, just to show one other thing with this map while it's out, if this is the map of the Earth or this is what we think it looks like, then the sun is required to go to the right like this, around clockwise. Okay, but here in Punta Arenas, when we looked west, the sun went this way. Completely the opposite direction that it's supposed to go. It's supposed to go this way, it went that way, and then it rose this way. Like what? How the hell did the sun do this? Well, it does that because it's actually lighting this area on the other side of the Earth, on the other side of the globe. That's there's a model that gives me an answer that goes, oh, that explains everything I've seen. Same thing with the sunset and sunrise going the opposite directions. Everybody in the north, every time we've ever seen, imagine this is the horizon, and we're looking west over water. Actually, be better if I just get rid of this whole picture. You can make a better sense of it. Okay, so let's say that we are, oops, let me get this. Looking out over the water.
Bro, on an
explain this to me.
An AE map preserves directions. It's an azimuth preserving map. So it's not going to be a different direction, bro. You've got a huge fundamental misunderstanding of conflating the globe and the AE map as a model.
Okay, so hold on, tell me this. So I'll go back to, let me just tell me this. You're saying that if this circle, let me go right this, let me grab a circle. If we take, let's just say this is the sun path. Get rid of that. Okay, so this is the sun path. So you're telling me that the sun always goes in this direction, correct? Meaning to the right.
I'm telling you how you perceive it is latitude dependent. So if you're in the north, you're going to see
Stop saying that. I hope you understand how dumb that sounds. Everything is latitude dependent. Everything in the sky. So stop saying something that is true every time.
And what else did I say in addition to that?
I don't know, but stop saying latitude dependent.
Single observer latitude dependent, bro.
No shit. That's how it works in reality.
Good.
Stop saying that, though. It's the dumbest thing I've ever heard anybody say. Latitude dependent. Of course it is. It changes no matter where you go on the Earth. It's going to change the sky. So it's latitude dependent. So stop saying it.
It's going to do that anywhere. That's how we perceive it.
Didn't I just say that?
If you're in the south, you're going to see it Antarctic. If you're in the north, you see it Arc. It's individual to you. We just went over how.
I thought you said that this is the map looking down on it.
Bro,
you have two different worldviews, dude. In one, you want us to believe in the real Earth that we're looking down on, then you want to pretend that there's a pretender.
Can you stop interrupting me, please?
No, because I was talking and you interrupted me. I asked you if the sun is moving in this direction, right? Isn't that true? If we're looking down at the Earth, is it not moving that direction? Or you're saying for some people down there, it moves the other direction?
Who's on top of the Earth looking down? We only
me right now. Me right now. We're looking at it
from a God's eye view. No. All you see is latitude dependent where you're at as the observer. And if you're everybody who's watching, you're going to see it go. You're going to see it arc. If you're in the south, you're going to see it Antarctic.
Right. So you're saying that the sun goes in two different directions, and we never see it actually change direction.
I'm seeing
because it has to go.
I'm saying.
Hold on. You're saying if there's a guy here in the south and a guy here in the north, there's two people here. You're saying this person sees the sun go this way, and this person sees the sun go this way. Yet nobody can explain why that would ever be the case, except for if you put it on a globe, then it all makes sense.
Well, you keep saying there's no explanation for it, but if you see it if you see it individual to you and it's just apparent, that's exactly what the cell theo is showing.
No, so what you've done now is you've taken the real observation from the globe. You've taken an observation of one thing going left and one thing going right, and you've said, well, that's what you see. It must be dependent on the person because we have to believe in a flat Earth, even though the globe answers it without any bullshit. It answers it.
So listen, when you say no bullshit, right? You're just talking apparent positions of the bodies. Any model can be constructed of that, as per Copernicus's advice to us. What I'm saying is that when
Okay,
you
right.
have,
Okay, so we can draw any map that we want and make it
I'm
work.
literally in the middle of
Okay,
saying
go ahead.
something. When you're just saying, oh, this body's here, this is where an observer saw it, we add 15 degrees per hour to it, it'll come back. That's what the whole model is based off of. What I'm showing you is that there's no actual physical elevation change over the greatest distance possible that could be measured.
Okay,
So hold on one second. So when you say, oh, this person sees their own sun and that person sees their own sun, that's the only way that I could physically explain why there's no elevation change. If there was an elevation change, I'd be a glober. It would be the single-handedly most conclusive proof you could provide. It would be that physically significant. There isn't any. It doesn't do that, bro.
Okay, yeah, and I'll figure out what you're talking about there. I mean, again, I'm a little bit confused on that one. I'll admit that. But on this one here, where I'm just talking about, this is the kind of evidence that should be end of story. Because again, if we look, well, let me just draw this real quick and we'll come back to this. But if we take this, I was going to draw it before, and I'm just going to say I want people to understand that the flat earth is trying to change this proof by saying, oh, well, it depends on which way you're looking. No, it doesn't. Because I'm not telling you to look in any direction but except for towards the sunset. So say this is water. I know it's purple, whatever, blue. There we go. And we're looking over and we're about to watch the sunset. So which way are we looking? Everybody should know. Oh, you're looking west. Obviously, we're looking at the sunset, so we're looking west. Everybody in the north sees the sun set like this, left to right. That's how every sunset is every day. Doesn't matter the season, doesn't matter anything. It just matters that you're in the north, the sun sets left to right. Now, you may see it set a little bit more like this, or if you're way up high north, you might see it set a little bit more like this, okay? But it sets left to right. Now, when it rises, now which way are we looking? Well, we're looking east if the sun is rising. And every time it rises in the north, it rises left to right. Everybody's in the north. We've never noticed this. We don't pay attention. That's the way the sun always will rise up past the horizon. It comes this way. Okay. Now, if you go to the south, now on a flat earth, there's no difference in between the north and the south. Why would it change? But if you go south, as soon as you go south, now the sun sets right to left. And every single where in the south, and it just changes, maybe it's this way. Towards the equator, it's going to be more like this. And if you are watching it rise, oops, too far. Watching it rises right to left. Okay, so now this becomes a paradox for flat earth. What you've just said is that two people on the flat earth, let's say this is the equator here, and you've got one person in the south and one person in the north. Those two people are watching the same sun go in the same direction, yet this person sees it go left to right when it sets, and this person sees it set right to left. So now what you have to believe is that Alan just says that, yeah, this person just happens to see it go to the left because it's latitude dependent. Yeah, we know that. But if we're asking which model
observer dependent as well, where they're located.
Of course it is.
That's the significant factor in this, bro. We're seeing an apparent object always. It's an apparent change in elevation. It actually never changes elevation. So how it works mechanistically, obviously the globe
but
says,
this person would actually see the sun, would see the sunlight on the water here, and this person's going to see the sunlight shining on the water here. Right? If you're looking at the reflection, I drew it above the water. This person's going to see the reflection of the sun here, and this person's going to see it over here. But you're saying that they're the same sun.
Well, everyone's going to see their own individual sun rays anyway. We know that from sunbeams on the ocean and also crepuscular rays. Everyone sees their own individual ones. It's a unique feature that no other light source in the world can reproduce. And you're like, oh, is it,
No, every light reproduces that.
It produces unique crepuscular and anti-crepuscular rays and unique sunbeams. It doesn't illuminate the whole entire area that it's illuminating.
It does, but you need to show me an example.
It doesn't do that at all.
But if you need to show me an example of us looking in a certain direction, so let's say we're looking at this as a wall or something, and we have to both see the same light moving in one direction, but we see it go in opposite directions. That's what you're saying happens. So we have to then say, which doesn't happen like when the sun's setting or something, we would see the light come to our feet at the beach, but it would come to each person. We don't see it going in different directions. Everybody sees the sun going the same direction.
Based on where the observer's at, the sunbeam comes to them.
Okay, that's a good point. So let me show you what you're saying now. If we had the equator here, let's just say, and there's somebody in the north and somebody in the south, and this person's looking out at the water watching a sunset, and this person watching a sunset. This person sees the sun going this direction, okay, and this person sees it going this direction. So now you're saying that that's because of it's an apparent position, and everybody sees their own sun. Mm-hmm. So tell me what happened. Why did it, when we crossed the equator, why would this change?
I have no idea.
Well, I'll tell you why.
I mean,
So
you could well
explain
see.
it.
So here's the thing. Here's the thing. You could tell me why you think it is, because Earth's a sphere, is what they would say, right?
Not what they say, but that's the only shape that actually predicts this. There's only one shape in the world, Alan, that says, oh, if you're on this shape, guess what? You're going to see the sun go in two different directions because you're standing opposite each other.
And if the shape of the ground was what you think it is, then there would be 4 million meters of deviation over that 7 million meter line.
Okay, you keep talking meters. I don't even know what we're talking about there. I'll go back and watch this again and get the actual measurements and miles so I can see what you're saying. I don't know if you're talking about something close or far away. Don't even have an idea. I'm serious. I don't know what you're talking about. So
it's fine.
I have to.
So
yes.
Listen,
but
like
I see what you're saying about the
disagreement that we're having is like,
and here's what I'll say to you. I'll say to you, if the Earth is a globe, then it must happen like you think it should. So I agree with you. So I'll find out why either it doesn't happen or it does, and you're mistaken. One or the other is true.
God bless. That was a main goal of mine to come on.
Okay, well, here's what people should recognize about me. The difference between me and another glober is that I'm still open to it being flat. Very open. In fact, I prefer it to be flat. I would like it to be flat tomorrow. Be great to get off the globe hill. However, for me, I cannot do that because in every instance, the globe predicts what I see. Okay, so if you're bringing up something that you say here, Jaron, does the globe predict what you see here? No, according to you, it doesn't. But I'm not going to just go along with you. I need to follow up with that. So I'll follow up with it because it is something that needs to happen on a globe. If you're saying it doesn't happen, I want to figure out why.
No, fair enough, because that was a big part of why I wanted to come on too, because I know a lot of the globe audience is going to watch this. Most of them will hand wave dismiss it, but there will be a few math lads that will look at everything, ask questions, and want to know the data.
That should be the goal. That should be why we have these conversations, because we should be able to get past some things. That's why I asked you those 3 questions at the beginning, because it's no use in me talking to people who want to say I didn't go to Antarctica, who want to say there isn't a 24-hour sun down there. It's just it's not worth my time.
Bro, the only reason I could argue this in good conscience is because the Celthio measurements did not go the globe way. Like, I was prepared to, like, when the FTFE thing happened, or I'm sorry, when the TFE thing happened, and we were all like, oh, we didn't expect that.
Yeah,
I wasn't gonna argue for it anymore until Mike proposed the null hypothesis argumentation, which was pretty good, but it still didn't quite feel as good to argue it. But then the self that we do with other people is that, like, a few dependent effects are mutually exclusive to the globe. So it's just, I just kind of like reiterated.
No, I mean, latitude dependent, I guess for me, that just means that it depends on the latitude of what you see. Well, of course, that nobody claims that it's not that. Nobody says, oh, it doesn't matter what latitude you're at, you're going to see the same thing. No, if you're at a different latitude than somebody else, you're going to see something different. It's like saying,
it probably comes off as like redundant, but a lot of the people that we argue with are trying to say that, like, that alone is mutually exclusive, and it's like, well, if we see it in
a little different color, this is the South Pole, this is the North Pole, and this is the equator. Okay, so what's crazy is that if we look at the arc of the sun, let me grab like this, let me do this ellipse. I mean, oops, not that one, this one. Okay, so this is the path of the sun. Okay, so here, so as you move to the south, it would start like that. South, I saw the sun unbend like this. Oops, damn it, I knew it was going to do that. The sun went down over here. Then when you go further, well, the sun lifts up until, guess what? You see this. Now above you, the sun just does this. Okay, and then if you're like, oh, I wonder what it looks like in the north. Well, yeah, 6 months later, because the sun moves back over there, you get a model that shows you that the north is the opposite of the south. Here's the model that tells you that, yes, at the equator on the equinox, you're going to see this. Then you're going to, so as soon as you got dropped somewhere with a blindfold on, and you saw the sun setting like, let's say this direction like this, you would be able to know, oh, I'm about mid-latitude, because it's not going to be outbent and it's not going to be straight up and down. This is about a 45-degree angle. You would know that you're at about a 45-degree north latitude. So the Earth is like, tells you the shape of the Earth. The sun tells you the shape of the Earth. You don't need NASA. You don't need Haversine formula. You don't need all these crazy, you don't need stellarium. You don't need to erase refraction. None of that. You can tell the shape of the Earth simply by watching the sun, period. And the sun goes the opposite direction once it's in the south. Well, this is the model that tells you why. The model that says that you're on a globe, and that as soon as you flip, so again, if you drew a globe here, I don't want to do it real quick, but I'll just do it for a second. So if you have a globe here, and you have somebody standing here and somebody standing here, that those two people are going to witness the sun, even though the sun's going the same direction, you're spinning the same direction, whatever one you want to believe, those two people are going to see it moving in opposite directions. So there's a model that explains and describes what we see. And so to refute it, to me, like you said, I would need to find parts of this model that don't match reality. For me, I cannot find that anymore. Now, you might say, well, Jaron, you've measured curve. No, not really. But I don't think I should expect to. I think that's pretty hard to measure curve on an Earth the size of our Earth. So don't expect to measure curve. Now, I have measured it if you're talking about my rocket launches. I'm 188 miles from Vandenberg. I can film the rocket launch. And when I go back and play it back with the live stream, I don't see the rocket on my horizon for 1 minute and 5 seconds. Count right now to 65 seconds in your head and realize how long that is from the point of time a rocket launches until I see it on my horizon. If the Earth were flat, I would see it quickly, not 1 minute and 5 seconds later. But guess what? When you do the math on the minute and 5 seconds, you figure out that the rocket's 34,000 feet. Then you go look into it and you're like, oh, the curvature of the Earth. Oh, guess what? Vandenberg is 34,000 feet below me at the 188 miles. So that,
dude, and if things like sorry to interrupt, but and if things like that were, if things like that were true, then the celestial theodolite measurements would show that curvature. Like the whole, how do we determine curvature and all that? That's what the celestial theodolite makes terrestrial measurements with respect to the with respect to the stars, like literally showing that there's no elevation change, like what you showed earlier with the sun at different seasons and times a year being at different elevations and locations. Is all
what did I show? What did I show?
Earlier when you just showed the tilt angle for the sun based off of where you're viewing it from and what season it's in.
Right.
So if all of that is based off of the apparent position, and that's why I'm saying what I'm proposing is unique, because this goes off the true positions and there's no physical elevation change, which is absolutely required if the Earth is truly a globe.
Okay.
Because just
and so
looking
you're
at
saying
the
that,
sun,
does the globe not say that is where the sun is? I mean, so in the globe Earth, I can pretend that the sun is real.
Not for the true positions. So if you were arguing that, then the true position would also be following the same arc as the apparent position, but it actually doesn't in reality. That's the significance of the deviation between the two. So we could see one as a conceptual model, and the other one is we could see the deviation from the conceptual model from what actually happens.
But you're saying, so on a globe, where are you saying the sun actually is? Then it's never where it says it is.
Even for instance, even they agree to that. Yeah, it's always apparent in both models.
Okay, but it's apparent by off by a degree, where yours is off by 180. Big difference.
Bro,
big difference.
Dude,
you're telling me what is the biggest deviation? I'm sorry, what is the biggest deviation of the sun?
Listen, you keep going back to the God's eye view version and saying that it's like a singular source that both people have to be viewing to wrap around.
I believe that the sun is a physical item. Hold on, I believe based on Melodone's work.
Bro, can I just? I'm almost done.
Go ahead. Go ahead.
I'm trying to get back to where I was. Just give me a second.
Okay.
You're still going off of the. I can't even get back to it, man.
Okay, but hold on. So you said I'm going off of the idea that the sun is a real item.
Oh yes, yes.
Go ahead,
dude, bro. Mello's dome work is kinematics. The whole globe model was built on watching the sun. You're not going to find a contradiction in sunspots throughout the seasons based on that. That has nothing to do, looking at sunspots has nothing to do with the shape of the Earth.
Okay, so on the globe, which we're looking at now, I'm standing at a place on the globe, I'm looking west, and I'm seeing the sun set. I want you to tell me, where is the sun really? If it's not, so you're saying it could be anywhere else.
No, I'm not saying it could be anywhere else. I'm saying it's following a circuit around us at the equator where it has a 90-degree GP for people.
Okay, but hold on.
Hold on. Let me just finish the thought. And people, you just asked me to answer the question about where I think the sun's at, and in the middle of doing that, you interrupted me.
Go ahead.
So
you're talking about the sunset. You're saying that it is. I asked if it is where this sun is when it's setting.
Yes. So what we're looking at here, the true position is just following a circle around us. What we perceive is the arc and the antarc and all of that. That is that is latitude dependent for the observers. That's why I've been reiterating this. So when you go back to the God's eye view of it and you're like, well, if an observer is standing here and the sun's over here, how can they see two different suns? It's like you keep
you're telling me that that's reality. You're telling me that you keep saying a God's eye view, but there's no problem of taking a God's eye view of reality. Who cares? It's just I'm getting above the Earth.
No one's ever seen it, and you're merging two conceptual models based off of apparent positions that don't truly change in physical elevation. That is the
No, I'm asking you. You
significance.
keep going back to that. I'm asking you. Let's just go simply, not go difficult. Let's just say simply. Can we get above the Earth and look down at it?
No,
Uh,
no,
conceptually,
we can't. No, not even conceptually. What
what?
would be the purpose?
Because I'm asking you a question. Like we need to know the layout of the continents. Do you not agree that they are the AE map layout?
Yeah, I'm
Okay,
sure that it resembles something like that. But
me too.
what we use to navigate it is two hemispheres of stars merged together,
Okay, but I'm not talking
based off
hemispheres.
of them saying that there's a physical
Here's what
elevation
I'm worried about:
change.
is when I was in Antarctica, I was looking south, knowingly looking south, and I saw the sun. Okay, that completely destroys what we just said about the flat Earth. It cannot be. I'm looking down at the Earth and I see the sun south of me in Antarctica because guess what? At that exact time, it's above the people's heads in Australia. So you need to explain to me if I'm either supposed to believe that what I saw to my south was some figment of my imagination, even though I felt the heat from it. The heat was coming from the sun. So therefore, it can't be some apparent position. It could be an apparent position that also generates heat, I guess. I'm not confused how that would even work. But the real sun is 30,000 miles behind me. So guess what? On the globe, I can pull up the globe like this, and that sun that I see, that's the only sun. Nobody else sees a different sun. That's the sun. I don't need a mystery sun. I don't need magic suns. I don't need refracted suns. That's the sun. And if it's above the people's heads in Australia, guess what I know? Australia's on the other side of that ball. That's what it must be.
You need a
It's easy.
physical elevation change for the sun as well.
Okay, I'm glad you keep going back to that because I already told you I will check into that. So you keep saying that. I'm hoping that it's as solid as you think it is because if it's not, you have to be a globe earther.
I know because you keep going back to the apparent position and reconflating it. Like we could just call it here.
There is no reconflating. There is the fact. It's a fact that in the south, people look south to see the sun, and it's the same sun that the people in the north see. Okay, so
I don't. The only thing I disagree with is that it's observer dependent, like individual to them. It's not the same one that you're looking at in the sense that you think it is. That you could like draw a triangle to a physical object.
Okay, but if you're looking at it and it has sunspots on it, then the other sun as well has sunspots in the same spots, right? So now the apparent sun carries the sunspots of the real sun. And how do we know which one's real and which one's not? We wouldn't know. They're just
know.
yeah. Okay, so that's what I'm saying. So really, what I'm being left with is there's two different models for me to choose from. One of the models where I can say see sun, there's sun. Okay, good, I get the sun. The other one is anything can go. I don't know what the sun's doing. I don't know if there's multiple suns and they all have the same sunspots, but I can't call them the same sun or else the Earth's a globe. So, I mean, anybody who's at this point stays a flat earther is very, very, very open to the ideas of magic and mystery. And even though you have to then believe God is a deceiver because God made the world that answers every question by saying sphere. That's it. Answers every observation we make from the ground, except for the one that you brought up. So I'll put that in there. If Alan's right that there's an observation, then I can no longer say that every observation that we make of the sky matches the globe, because according to Alan, it doesn't. But I haven't got to that point yet. I'll report back. But if it does, then every observation matches the globe perfectly. The globe describes everything. The flat Earth doesn't describe anything. In fact, it requires you to believe that the sun could be anywhere. We don't know where the real sun is because, yeah, you might see it in the sky, Jaron, and it might be heating you up and it might have a hot spot on the water, but it also might be above Australia's head 30,000 miles behind you. So you just have to, whatever. I guess it's just mystery. For me, I don't like that. That feels very weird. Whereas the globe, yeah, it feels weird because I don't feel like I'm on a globe. I don't feel like I'm spinning around. I don't feel like I'm on a ball. However, if it answers every question and every observation I make, guess what? I live on a ball, period. There's no way that it could answer every question. And actually the truth be that God just deceived us. He said, I'll put this sun here and make it look like it's a ball, but really it's a magic refraction, double-sided, double helix firmament dome that happens to just make magical qualities where the sun appears wherever it needs to be. And it just so happens that the sun happens to be where it would be in a globe. It's really weird. Really weird.
Can I comment real quick on the God
let me
deception
talk.
thing? Okay,
Yep.
so I don't think that's necessarily the case. When I looked into the history of Japanese cell nav and Chinese cell nav, what I found was they actually invented celestial navigation. They invented the celestial sphere. They went to the south, mapped the same thing. They had their own way to determine latitude based off of shadows produced by the sun throughout the day and year. And then they also came up with a ratio for when they would change in length to determine latitude. So they had a whole system for all of this. They had a whole system for categorizing stars as they transited over the Beijing meridian. And they actually changed their cosmology from being geocentric flat earthers with the kind of like conceptualizing it as a square. They actually changed it to being rounded because like the way that they see is still flat, but they changed the way that they talk about the heavens and stuff, because what they realized is that the heavens that they see, the celestial bodies that they see, aren't real. And it's like they were talking about it as an illusion, and like it's an apparent thing. It's not physical. So their whole cosmology was based on knowing that what you see in the sky doesn't represent physicality, and that you don't actually see that, and that there's a limit of vision. They actually derived everything that we're using right now for cell nav to the direct equivalent, because what happened in the 1600s is the Jesuits came by and basically stole their whole methodology and then reproposed it as it was derived from Greeks, with all this missing history where there's no firsthand information. Bro, there's firsthand documents from like all the Chinese stuff where they invented trigonometry and all this stuff.
You need to talk to Austin and remind him that him and I found this paper that was written by some Japanese guy in late 1800s at one of the world's fairs. And in all the documents we can find, it says that he had a working model of the flat earth, and that it was based on ancient Japanese or Chinese, whatever. And it was a working model that everybody could go see at this world's fair. And no matter what we looked at, we could not find any description of it. Oh, you did?
Yeah, I'll pull it up real quick. I'm screen sharing.
Okay. Are you talking about this same kind of people that are doing, you found it? Where did you find it? I know we couldn't find it.
So somebody linked it on Telegram, like the image of what it was, and I didn't know what it was specifically, but I was like, oh, I'm pretty sure I know what that was. So I started started the investigation, and I found it. Give me 1 second. I'll pull it up. And
right. And it was the guy who displayed it at the World's Fair, right?
Yes, sir. Yes, sir. Give me 1
Yeah, because I would like to see that, because again, what the difference is, what you're describing when you said it's based on longitude, latitude. Well, longitude, latitude have the North and South Pole. So
yeah, dude,
I can't really picture a flat Earth person or a flat Earth group using longitude, latitude, because what it means is that 0 degrees is in infinite places. Sorry, it's 0 degrees, 90 degrees south. Sorry, it's not 0, 0 would be the equator. And 90 degrees south would be an infinite amount of places, right? Because it's that entire circle. That's what's crazy about when like Duffy asked Flatzoid where the South Pole was. Because, oops, what am I doing here? Clicking on OBS instead of this. When he asked him where the South Pole is, because the crazy thing about this map is that the South Pole is everywhere out here. This is the South Pole. Even though it's one spot, it's all these spots.
Yeah, but that's a projection of the coordinate system. So like, that's not, it's fine, dude.
Right, but I get what you're saying, but you're not allowing us to understand what the real world is. So I understand that this is a projection. Okay, great. We can say that. But I think that the world has to have a real shape, meaning if we really got above it conceptually, wouldn't it look like this? And the answer is yes, if the Earth is flat.
I agree. It does look something like that, but we use a coordinate system derived from the stars from our position on the ground. But
right, but we use the distances. We use the distances based on that as well, meaning that if you find two places in this near the South Pole, their distance would be very close to each other. However, these two distances would be 40,000 miles away.
Well, the distances
in real life
are going to be internally consistent because a meter is a ratio of the terrestrial meridian itself. So any distances you
that's a globe proof.
What? It's a ratio of a coordinate system, bro. It's not a globe proof. So
it is, because the coordinate system is a globe.
The coordinate system is spherical. It has a
bisecting
meridian.
So you're saying that the distances are matched. Of course they match, but they don't match this.
When we both talk over each other at the same time, it's super productive. Let me tell you about this model real quick, and then I got to dip.
Okay, I got to dip too. Go ahead.
All right. So here we go. This is what was found here, and what we see is.
Oh, sorry, bring this up.
Sorry, yeah, we see the equatorial plane and we see the celestial here. You see these domes here. These domes represent how you see the heavens, and they're separated to represent 4 different continents. The way that they conceptualized it is that there was like a localized dome over the continents that projected the stars in the way that they see it. And what they have over here is a central axis that extends up. The way that this works is that...
Does that cause the eclipse?
What? Can you just...
I wonder if he says that it causes the eclipse. Could be that the sun goes behind there and then it just flashes, the light wouldn't get across, it would block the moon. Go ahead anyway. I mean, it would show the shadow on the moon.
Bro, this is a fucking conceptual model to hold up things that are dangling that reflect light on the
Yes, I know.
mirrors that are here. So that's just...
Okay, go ahead.
So there were strings attached to here, like little chains, and they had gemstones and different metals on them. And then you would shine light on them so that they would be reflective. And then inside of these little areas here, these were little glass domes that have latitude and longitude on them. And the celestial bodies, as they go in a circle above us, get displayed as different arcs. And then as this was set like as a planetary gear ratio, where once it completes 90 turns, it's basically changing in elevation as it's going up and down. So what you'll see is the positions of the celestial bodies change in the reflective dome here, creating a north and south pole. They had all of this all mapped out. So like when you translate what all the stuff means here, this is like they knew all about this, and they didn't change cosmologies to be globe lads. Like it wasn't until like the late 1800s, about 200 years after the Jesuit influence, did the Chinese change to being globe lads. They had a whole system of navigation, latitude and longitude, that's completely identical to what's used today.
Right, but I mean that wouldn't ever be able to match reality because again,
they were the first people to sail around the world. What do you mean?
Okay, I didn't say you can sail. It doesn't. You can have a model that you've brought up 2,000, 3,000 years ago that allows you to sail the Earth. It doesn't mean that it's the correct model of the Earth. So when you go back to that model, how could you have stars that are circumpolar, like we looked at earlier in the south, on this model? It's impossible, Alan.
It's impossible. It's not impossible, dude.
Oh, so show me how jewels are going to hang from those strings that are going to then circle the South Pole when they're on the other side of that little stick.
Listen, whether or not it's possible to demonstrate or not, the Chinese did it, mapped it out. It works.
That doesn't mean we live there. I don't understand what you're saying.
It doesn't mean that we live there, that they merged it together and you can do it now.
You cannot make the stars do circumpolar around the South Pole star. You can never do that.
No, nobody needs that to happen, bro.
That's what happens in reality.
They literally invented the celestial sphere in the north and in the south, mapped it together. You think they weren't smart enough to go, oh, you know what? This probably means we live on a sphere. 200 years of Jesuit influence before they accepted it.
Right. So why didn't they we'll just go along with these guys that are telling us things that aren't true?
Using the same system. Yeah, basically.
Okay, well, that doesn't make any sense. People who came into a observatory and said, hey, this is the actual truth. They would go, no, it's not. This is the truth. We make better observations. Guess what? They came in there and they made better observations and better predictions. And then the Chinese said, it's a globe.
Name the better observations. There was a 13-second
I just told you.
No, you didn't. There was a 13-second deviation.
Is there circumpolar stars in the south?
They used these circumpolar stars to navigate in the south. They mapped them out and made a whole latitude longitude system based off of eclipses. Bro.
Right, but this model doesn't work on that. How are you going to make stars circumpolar in the south?
This isn't the model that they use. Number one,
oh,
you asked me about a thing that was in a world fair, and I told you what it was and told you how they said it works. That's all.
Right, I was hoping that it would explain things, but it doesn't explain things because that cannot work with what we observe in the south.
Well, bro, you haven't even seen the dangly stuff on it reflecting at different altitudes, so I don't know if it does work or not. But that's what they said. This is what it was based off of.
And that thing turns once a day, right?
No, it turns however you turn it. However many times, however fast you turn it, and then it's set on 90 turn intervals, so it raises and lowers in elevation per 90 days.
Right. So 1 day is one turn.
Sure.
So I'm just saying that the stars that are on the inside of that disk at the top would be the northern stars. The ones on the outside of the disk are going to be the outer stars, but they go all the way around the outside. Yet in the little dome down there, it only can go around the other side, and they have to stay within this Sigma Octantis, which just isn't possible. It's just not possible.
It's not possible. Yeah. All right.
Yeah, that's all. But I will look into what you said. I will make a video about it or get back with you and we can have another meeting because I agree with you that the globe Earth, the reason I'm a glober is because I've realized now that it predicts all that I see. So until it doesn't predict something that I see, then I can have a problem with it. So for now it does. As far as the sun and moon, that whether they're upside down or not, whether they're moving in which direction they're not, everything matches the globe. And then the other thing is I've never found anybody who has been able to debunk Google Earth. So Google Earth places everybody that we know on a sphere and shows them what their observations would be. So one person out there better be able to say, Jaron, I live at this location. I'm looking at what Google Earth says the sky will do, and it's doing something different. And you won't find that. And so where does that mean that we live? You guys want me to believe that it's possible for them to place us all on a sphere and our observations match everywhere on the sphere, but we're not really on a sphere. And if that's true, then just show us another version of something that matches the same thing, but you'll never do that because it's impossible. How could you show something that matches the observations of another place, even though it's a different shape completely? It's just not going to happen. But go ahead, tell everybody where they can find you and how they can get more information and where they can do that themselves as far as the cell theo or whatever you call it. What is it called?
Yes.
Oh, I have to read the rest.
The celestial theodolite. So yeah,
Sorry,
if you want
can you stay for 5 minutes if I rush through these super chats?
yeah,
I just want to know if there's any questions for you. I'll get past the ones that aren't for you. So for the eclipse simulation, did Alan account for the fact that the personal dome would cause each observer to see the sun and moon at a different position in the sky?
Yes.
Okay, I would think so. Okay. Yes, the answer. Thank you very much, Pink P. Floyd.
It's based on the angle that the observer saw it at, and then the distance of the triangle. So yes.
Okay. Mr. B6034 says, Alan, is it possible that you have a mistake in the calculations that you have made in your celestial theodolite?
It's highly unlikely. We're at 24 weeks of celestial theodolite updates. No one's refuting the math. It's always like trying to attack the methodology or the analysis.
Okay, we got Sick Doctor 1 says, how is it that now you can use the lights in the sky to determine the shape of the Earth?
Well, I was never bound by any sort of dogma, and the entire globe model is laid out based off of looking at things in the sky and the apparent positions. So the best way to refute that would be to find a way to show that the true positions don't change in elevation and that's always apparent. That would be a good start. So that's why we went with that. It's dogmatic as hell to say don't look up at the ground, because a measurement without an external reference is just circular. So like if you were to, like if you were to build like a force the line situation that's literally attached to the Earth that could exist on either model, doesn't prove either. It's like using a ruler to measure itself. It's retarded.
I agree. Okay, good. We've got from Jesse says, looks like a globe, but it's just an illusion. Yeah, yep. Okay. Science Minded says, see email for printable model for Alan, etc. Simple geometry of 6 airports. Wait, Science Minded says, see email for printable model for Alan, etc. Simple geometry of 6 airports. Okay. Jesse says, Alan lied again. The difference between flat and globe is 25 miles is 400 feet and easily distinguishable. His method fails in a lot of cases. Okay. We've got fake super chat for $420. Thank you very much. I do appreciate fake super chats. My favorite. Only 4 left. Galaxy Soup says, can Alan explain why never in recorded history have we seen the sun's angular size change over the course of an entire day from sunrise to sunset, confirmed simply with a solar filter? Well, it does change maybe a small, tiny bit, but not nearly what it needs to. Do you have an answer?
Yeah, my answer is that if we don't see the physical sun, what we see is an apparent object.
Okay. We've got Sean Hawkins 666. Alan, Antarctica isn't named that because of its Antarc. It's because there are no bears there. Arctis is Latin for the bear. Okay. Jesse says, by answering it's just apparent position to every globe evidence, Alan's basically conceding that according to our senses, Earth appears to be a globe. Huh? I mean, he says, by answering it's just an apparent position to every globe evidence, Alan's basically conceding that according to our senses, Earth appears to be as a globe. So you would say that, yes,
that's my premise. The whole globe was constructed from watching the sun and the stars. We've done tons of presentations on it. Like it's our premise.
And Pink P. Floyd says, Alan, does the apparent sun provide apparent warmth or real warmth? It's a good question.
Ooh, great question. There is a huge asymmetry in the climate in the south versus the north in terms of being directly at the poles or whatever. So,
one's water and one's 10,000 feet high. It's a little kind of different temperatures there, water level or 10,000 feet high, different atmosphere. Okay, that is it, I think. Thank you very much, Super Chatters. Do appreciate that. All right, now you can say your final word and where they can find you and get more information on the
All right. If you want more information on the Celestial Theody, you can go to publish.obsidian.md/spaceaudits and click on the Celestial Theodolite section, in particular the bounty section, if you want to learn how to participate. Like I said, we do have a prize pool so we can get some more terrestrial measurements. If you want more information about the eclipse, click on the eclipse tab. You can see the PDF that Brian made for us. He has all the math and everything laid out. And then in the comments, there was a couple of comments from some people on YouTube that had questions about the data and all that. The PDFs and responses to those questions are in the documentations here. If anyone has any meaningful, substantial refutations to the math or the process that we used for the eclipses or the celestial theodolite in general, just send me an email with your critiques. Doing it in PDF format would be preferable. That way we can go over, individual points and go point by point and stuff. If you want to join the discussion and talk to us about it or whatever, we have a Discord channel dedicated to it. It's called the Cell Theo, but you can find that on our Discord. That's discord.gg/ethercosmology, and that's ether with an A. And if you want more YouTube stuff, my YouTube channel is at @space_audits. You can go there. We do celestial theodolite updates and discussion every Monday at 8 p.m. Eastern. So if you want to discuss the celestial theodolite, you can go to, we actually do that on Earth Awakenings. It's a more public server because we've banned a lot of people from ours, but we go to to a public server and have our update there. So anyone's free to ask questions and stuff, et cetera, and go over the data. Sadly, there's been a lack of participation on the globularist front, and everyone's relying on our boy Jesse over there to disseminate all the information about it.
Yeah, no, it'd be good if some people did look into it and at least get to an answer there. Because again, if we can start to show some of those things to be false, that Alan even said, if you can show that change in elevation, then he sees no reason to remain flat. So it's something we should work on, and at least, or at least I need to know. God, I guess in my eye. At least I need to know why it is that the observation is not matching the globe, because I'm under the assumption right now that there isn't any observations that I've seen or heard of the sky that don't tell us that we live on a sphere. So if we don't see an elevation change from each person, then there's a problem.
Yeah. And not only did it not match, the globe, so-called, it actually contradicted the Kepler/Newtonian distance that they give, which I don't know if you're familiar with all that stuff, but it's basically how they derive the distances to all the planets and stuff. It's just a ratio of how long it takes to complete a circle.
Oh, and I've said that before, right? Yeah.
Yeah, over the time it takes to complete it. So the distances could be anything, but they're set on what was calculated from Kepler, and then they can also derive newtons from that. And because they're using big G and big M for that, they're asserting like, okay, it must be this distance, therefore, and that based off of this mass, there's this much gravitational potential between them to cause this velocity over this distance to complete that circle. So it actually contradicted that as well.
Okay, gotcha. Any final words? Anything else you want to say?
No, that's it, man. Thank you. I apologize for getting heated, and I probably probably gave some snarky looks and stuff at you, but
it's all right. I'm okay with it. I'm accepting it. All I care about is getting to the truth. I feel like I've already got there. So at this point, I have to be ready to, take people coming at me with apparent disproves or debunks of the globe. So let's see if they happen, if they stay up, or so Jesse can still ask questions and y'all answer.
No,
that's my spin.
No, you can't actually ask questions if you're on screen showing the equations, going over the math, been given several PDFs in the same time that you're saying that you haven't been given the math, and saying that it's a different math equation, even though a new equation hasn't been shown to be where it's different. Like, you can't just lie endlessly and I'm still going to talk to you. That's literally retarded. I'm not doing that. If your answer is just to lie and obfuscate, you can't participate. And that'll be determined. And that was determined over the course of like 15 episodes where we gave Jesse unlimited time to speak and answer all his PDFs. We even did the PDF exchange program with him because the stuff he would start critiquing was just ad nauseum ridiculous nonsense that had nothing to do with refuting the actual null hypothesis or showing how the elevation change is being physically demonstrated for the globe. So if you're not doing that, then you're doing something. Yeah, if you're not doing that, you're doing something else. And if you're doing something else, you can do your own presentations about the thing that's not what we're doing.
Okay, I just love liars in the chat. It was my favorite. So this person says here, Jaren bans anybody who disagrees with him, which I have not banned anybody. I don't ban anybody from YouTube. So if one of my mods did, then you'd probably have a problem with them, not me.
Dude, I'll say this. I often ban people I disagree with.
So he says, once again, Jesse, once again, a liar. Plenty of Globers on Ether cause, just not liars like you. Jaren actually bans anyone who disagrees with his recently found retardation. No, I don't. So I don't know what you're talking about. It's a recently found retardation. It's so funny. It's just funny to me. I'm supposed to believe this guy in my chat, Galatrix Bear, he's smarter than every single physics professor in every single college that there is. That's what I have to believe. So who do you think's more dumb there? Me or him? It's like, give me a break. This guy's smarter than every physics professor that's ever existed. Same reason why surgeons are not playing Operation at the childcare. Nobody wants to give them the view. Oh, sorry, don't know what that is. Just seeing somebody said I don't look at the chat. So when I'm having a debate or talking to somebody, I try not to, or else I've seen it happen. I remember I was moderating debates and I would see people looking at the chat the whole time, and then they would just be terrible in the debate because they weren't paying attention. They were not even listening to the other person. They cared more about what the chat says, and they even change what they're going to say based on what the chat says. I don't want to do that. So I don't do that.
Same. And you're so right to do that. That's why I don't look at chat either when I'm doing stuff.
I've seen everybody, they become who their chat wants them to be. I can name 10 people that are exactly what their chat wants them to be.
Yeah.
Rocket launches are just skateboards paying ride to the dome. Oh, that's just a joke. All right. I was just thinking if there's anything else there. So is Alan and Shame at Jaron? What? Jaron, Alan banned me in less than 10 seconds when I said hello on the Ether Derpology server. I have it on video. That's from Max.
Yeah, like I said, I do ban indiscriminately and for completely random reasons. I have no idea who you are, no idea what you said. If you got banned for just saying hello, you probably said it at the wrong time.
Okay. I mean, it's scary to think about, though, that, I mean, you do realize that is a pretty vicious echo chamber, calling it ether cause or whatever that is, right? I mean, that's what an echo chamber is, right? If nobody really.
You're going to start critiquing something that you don't really know anything about or why.
I'm asking you as a question.
Who the history of that guy is. I don't
know. No, I just
guy.
asked you a question. I said, your ether cosmology is a pretty big echo chamber, isn't it? No, you can say, no, it's not. We all disagree all the time.
Sorry, I misheard you then. No, we have globe lads on there that disagree and provide meaningful substance advice and stuff, like for the math and everything. Like it's a mixed group of people, man. What we don't tolerate is like just outright lying. Like that's absurd. And people that do that and waste time and argue endlessly with no conclusion over stupid shit. Like this isn't the place for that. Like, so.
Yeah, no, I get it. I mean, if somebody has a direct refutation, they should bring it like in a PDF form or say, they can come into my channel and present. I don't care. In a condensed version, but you should be able to show why somebody's wrong about something or why their understanding of it is wrong. For instance, if he's wrong about the drop of the sun and moon or whatever, then we should be able to explain it easily why he's wrong. It shouldn't take.
We don't even know what that guy in particular is wrong about, though.
Yeah, I don't know.
So
says
like,
I banned,
and that's the thing. Like, doesn't matter, but if like people that are on other servers, right? Because it's a small community. We're all on the same different servers, right?
Okay.
And what people will do is they'll be on one server. You give them an explanation to something, then they'll be on another server and be like, I've never heard an explanation to this. Like, we don't do that shit here. And like, if you behave like that, you can't come and be a part of our community. If we want to interact with you, we go to whatever server you're on and do it that way. Like, we're actually doing research, looking for meaningful refutations. If something gets refuted, the argument gets dropped. It doesn't go anywhere. Like, we don't, like, if you come in and do nonsense and you're a nonsense person, you get shown the door real quick.
Okay. See if there's anything else here. Send your fluids to Foundry. Alan says he doesn't tolerate lying after spending 3 hours lying. Shame because you can't handle the math. All right. I think that's everybody. All right. Thanks, Alan. Appreciate it.
Sorry. Like real quick, like that's a perfect example. Just spent 3 hours lying. I just spent 3 hours showing, data of no elevation change, like the significant takeaway from this, but it's like, I'm somehow lying about that. That's literally.
Well, I'll find out about that. It's going to be one or the other. Either it was a lie or it's true and it needs to be explained. So one or the other.
Yeah.
So I appreciate you bringing that information up because I think it's good. And I think if Globers would have handled things a little differently, maybe this wouldn't have gone as far as it did, because I do think that, like, if I now just go make fun of Alan and call him a bunch of names, and then I'm not getting anywhere. That's not going to change his mind, and it's not going to change my mind. So instead, I'll take what Alan is saying, and I'll go and weigh it out and see what happens, and then try to bring it back to him and say, this is why you're wrong, or I have to explain why if he's right. So that's the way it should go, rather than just laughing. I get why Globers do that. I get that for the most part, it seems like at this point, it's like a foregone conclusion. But I still think when somebody's got a legit reason, I mean, we have to believe Alan. We have to take him for what he's saying, that he said he would be a globe earther, just like I would say before, like, oh, if you show me 24-hour sun footage from the south, I would be a globe earther. So Alan's made the same claim here, that he would be a globe earther if we showed drop in those celestial bodies. So must be a reason why it doesn't show drop. So let's figure it out. That's all I'm saying. Sound good?
Well said, man. Appreciate it.
All right.
It was nice catching up with you.
You too. Take it easy. Later. Guys, what do we have coming this week? Anything else? I've got tomorrow. I'll be on with, I don't know if he's recording.
All right, lads, I'm going to wrap up now. We'll be on the EtherCause Discord. If you're not banned from there, the Discord is discord.gg/ethercosmology.